Good afternoon and most welcome to today's seminar, Creating Value Through Closure. We are broadcasting live from a studio here in Stockholm. My name is Emma Hadmark and I'm a Director of Communications at SveMin, the Swedish Mining Association. And yesterday, we at SveMin, we launched a new report where we are striving for more efficient permitting processes on how to start a new mine. But equal important is the other end of mining, the closure. In the epicenter of this topic that we are about to discuss today is for how long should or must a construction be designed to last? Is it 30 years or is it forever? And who or what should be monitoring that? And in what state ought a piece of land be that is returned to nature? And what could that piece of land be used for? I guess the key message today is that keeping the closure in mind at an early stage, way before it actually begins, will make it easier later on. And these long-term closure plans made already during the active mining production phase will save time and money and eventually the nature. Today, if you have any questions or comments on what we are talking about, please let us know. Share your thoughts and do that in the chat box. And the chat box you will find on the YouTube window if you exit the full screen mode, and you will find it on that side. So, and if you find out that you are unable to write in the chat window, you need to log in to your Google account. That could be, for example, your Gmail. So do that, and please let us know. And we have seen the participation list, and we can tell that there are a lot of experts out there. So please help each other out to answer the questions and bring clarifications if needed. But if we have time, we will try to answer a few of those questions here during the broadcast in the end of each session. So if you write a question that is directly direct to the one of the presenters, the speakers, please specify that when you write the question, and we'll try to pick that up at the end. Today's seminar, again, to the structure of this, has 4 sessions, and in between each session, there will be a short break. So there's no use to be multitasking during the session. So please listen carefully and then use the breaks for checking emails and so forth. Our first speaker today is calling in from Kuopio in Finland. And she is currently an environmental specialist at the Finnish Mining Association, and she will be discussing and telling us about license to operate, what should be done, and how to achieve this license. So please welcome Hanna Lampinen from FinMin.
Thank you, Emma. So as Emma mentioned, I'm gonna give you an overview on license to operate today and tomorrow. And just to make sure, did my slide change? Thank you. So first, shortly about myself. So as Emma mentioned, currently I'm working as an environmental specialist at the Finnish Mining Association. And I worked for it around a year and a half. And prior to that, I worked around 3 years for Yara-Siilinjärvi, which is a phosphate mine, and around 9 years in Kittilä for the Agnico Eagle gold mine. And there's my contact information if there's any questions or comments after the webinar that you want to ask. And then very shortly also about our association, so the Finnish Mining Association. We are a lobby and advocacy organization for companies operating in the mining industry in Finland. We've got around 50 members, which include mining operators, contractors, suppliers of technology and equipment, service providers, and exploration companies. We are fully financed by our membership fees, and we were founded in 1999. Our offices are located in Helsinki, although my office is here in Eastern Finland in Kuopio. So then to the topic itself. What does license to operate actually mean? Well, it means that you've got the social acceptance for your project from the stakeholders, such as landowners and NGOs and so on. So it's not a license that you can apply for. It is something that is earned. Well, how is it earned? How can you have it? I think that the most important thing is communication. And when is it earned? I'd say that throughout the project. So from exploration to closure and even to post-closure. And a bit more about the communication, since I think it's the key to social acceptance. What to communicate and to who? Well, first, it is very important to recognize the stakeholders of your project. For example, the local municipality, reindeer herders, indigenous people, landowners, and so on. The second most important thing is to contact them in a very early stage. In Finland, we've got this so-called reservation phase prior to exploration. I know that you don't have that in Sweden. But this reservation means that the company has the privilege to apply for an exploration permit to that specific area. So the reservation doesn't give you, or you cannot do any exploration work with the reservation. These large reservation areas have caused a lot of negative comments, especially in the social media in Finland. People seem to think that these reservation areas mean mining. And of course, it's not like that. The reservation is going to be changed in the Mining Act, which is being updated at the moment. So at the moment, the companies can make reservations for free. But that won't be the case in the future anymore. In the future, there will be a payment per hectare. And hopefully that leads the companies to make smaller reservation areas and actually think about the reservation areas. So what to communicate? In this early stage, you should communicate what kind of, for example, exploration plans you've got, the timetable, areas of exploration, mitigation measures regarding, for example, protected species. And also in the mining phase, it is very good to communicate your plans for the future, and especially communicate what kind of technological methods you are using to minimize the environmental effects, for example, water treatment. And in bigger picture, it is also good to communicate your plans, the economics of the project or the mining industry, and also remind people from time to time why the modern society needs mining. Well, then how to communicate? Well, first of all, in local language. In Sweden, in Swedish, in Finnish, in Finland, in Finnish. And you can use company website, newspapers, meetings, open house days, and so on. All in all, I think it's very important to meet the stakeholders face to face. Well, here are a few examples of the topics that mining industry is communicating in a bigger picture. We all know that the climate change is a big global concern, and everyone knows that we need to move from fossil fuels to renewable energy and electric cars. This means that the need for many metals will multiply in the future, and recycling cannot meet this demand, so more mining is needed. Also, the production of mining products has become more climate friendly. For example, just recently, LKAB announced carbon-free iron ore, Boliden announced low copper, and Terrafame here in Finland announced low carbon nickel sulfate. Well, in Finland, one good way of communicating about sustainable mining and hopefully gaining some social acceptance is the Network for Sustainable Mining. The network was founded in 2014. It offers a neutral forum for the interaction of mining industry and its stakeholders. Members of the network are, for example, Reindeer Herders Association, WWF, and Nature Conservation Association, and of course us, the Finnish Mining Association. The network has created a standard for sustainable mining, which is based on the Mining Association of Canada's towards sustainable mining, so TSM. It has 8 tools: community outreach, biodiversity, tailings and water management, energy use, and GHG emissions protocol, health and safety protocol, crisis management, and mine closure protocol. And this year, the network published a standard for sustainable exploration, and it has 3 different tools, which are community relationship, environment, and safety. And mining and exploration companies operating in Finland assess their operations against these tools every year. And this year, for the first time, we had an external audit. And then the network has also created a social responsibility report that the companies report yearly. And since the network doesn't have only members from the industry, it has not always been easy to have a common understanding on what to write on the standards and what to demand from the companies. But it hopefully brings more credibility and transparency to the standards. And then to my last slide, since the topic was license to operate today and tomorrow, quickly some thoughts on how to improve the social acceptance in the future. Well, I think communication is still the key. You cannot forget that. But I think that we also need to improve the continuous risk-based closure planning. Thank you very much.
Thank you, Hanna. Very interesting to hear about what's going on in our neighboring country of Finland. You mentioned that this reservation phase prior to exploration is something that we don't have in the Swedish legislation. I don't know, is that equal to inmutning in Swedish? I don't know. Maybe some of the experts out there watching could clarify. Anyway, I understand that this reservation phase has caused a lot of negative comments in the social media, for example. Could you explain a little bit how, why?
Good question. I think one of the reasons is lack of knowledge. As I said, people seem to think that when a company reserves an area, it automatically means that there's going to be mining. But I think it's also due to the fact that some companies who come to Finland and reserve these large areas don't know the atmosphere that we've got in Finland and don't understand what kind of discussions and comments is being told about mining. And these reservation areas, as I mentioned, they can be quite large. For example, just a few months ago, there was this one 300 square kilometers in the middle of Lapland. So of course, people, when they hear that there's a reservation from an exploration company, they immediately start to scare that there's going to be a mine. So I think it's partly lack of knowledge, lack of understanding from some of the companies, maybe.
Is that apply, if I understand it correctly, that mostly apply to the foreign exploration companies then?
Maybe so, because I'd say that most of the companies that are our members and have been operating in Finland for a long time, they understand the public opinion about exploration and mining, and they understand that they have to really look into the map and make the reservation areas smaller, and not just like take the half of Lapland and so on. So I'd say that, yeah, pretty much.
You're also talking about one of the key issues is that to gain this social license to operate is information or communication. There is a lack of information out there about mining and especially about exploration. Do you believe that the mining companies or the exploration companies, should they do more than is required in the law? Should they go like beyond the law, or is the law enough, or should the law itself be changed in order to, so to speak, gain more acceptance in the end?
Well, the law is being changed at the moment in Finland, but I'd say that at the moment, definitely the companies should do more than the law requires. As I said, for example, open house days and meeting face to face and actually letting people to see what you're doing, telling them what are your plans in the future and what's the timetables and everything. So yeah, I think face-to-face meetings are the most important ones.
Yeah, and increased transparency, if I read you correctly.
Yeah.
And what do you see as the biggest risks in the future in gaining a social license to operate?
Well, I think that one comes from the EU level. There's this EU taxonomy, which is the classification system for listing environmentally sustainable economic activities. And as probably many of you know, we don't still know whether or not mining industry will be on the green list or will it be regarded as environmentally sustainable. So if the EU sees that mining is not environmentally sustainable, then how can we as an industry tell people that mining can be done in a sustainable way? As I've understood that when the EU taxonomy has been discussed, there's been examples of mining outside EU. So yeah, I think that is one big issue.
Yeah, I do agree. There's a lack of knowledge in the EU too, in Brussels too, about the mining that's being going on, especially here in the Nordics. I fully agree that there's a vast, unknowledge or misled, people being misled. I fully agree on that from my perspective, working for SveMin. I bet that was the last question for me to you, but so now I'm turning to our viewers and participants today. Do you have any questions for Hannah? Please let us know and post your question in the chat box, and we will try to answer them at the end of this session. So thank you, Hannah.
Thank you.
Now we slightly change topic and going to talk about acid mine drainage. Because acid mine drainage from mining waste is especially challenging to deal with in this long-term perspective that we are talking about today. Should the piece of land be remain in an industrial site, or could it actually be fully recovered and turned into a playground for children, or could it be a healthy grazing ground for reindeer? Our next speakers will be addressing these issues from a very technical perspective, and they will be talking about a method, a failure and effects mode analysis in closure, and AMD management to minimize risks and create opportunities in closure planning, and using the Kevitsa mine as a case. So Seth Müller is currently a development engineer with Boliden Mines, and Stephen Pearce is a technical director of mine environment management in Wales in the UK. So I say welcome to our next speakers, Steve and Seth.
Thank you very much. I'm going to go ahead and start out the presentation, and about halfway through, Stephen will take over. Quick agenda here, talk a little bit about risk management and the FMEA and how it works. I'm not going to go into a lot of detail, but I'll sort of walk you through an overview and a little bit how we've used the tool. And then I'll give you a quick introduction to the Kevitsa mine in northern Finland and talk a little bit about how we've used that process in Kevitsa. And then I'll turn it over to Steve for actual examples of some of the work we've done. So understanding risk and communicating risk is a really important aspect during both the development of mine and the development of the mine's eventual closure plan, which is obviously ongoing from the day you decide to build a mine. A failure and effects modes analysis is a tool that we use to inform on that design throughout the life of the project. Generally speaking, it's a top-down expert system approach to risk identification and quantification that allows us to suggest mitigation measures throughout the life of the mine and identify and prioritize these mitigation measures to see how we can better improve the closure plan with time. It's really important that everyone understands that this is not something you do one time. It's something that you continuously do over the life of the mine. And this can be because of changes in the mine itself, or it can be based on changes to investigations, et cetera, that you've done along the way that suggest that you may need to change your track and do something differently. And before I go too much further, I'll go ahead and acknowledge that a lot of this material is from MEND, and a lot of the graphics on my slides, at least, are from O'Kane Consultants. That has been a big help in helping us through our FMEAs in Boliden in both Kevitsa and Aitik. The FMEA isn't just a risk tool, it's also a communication tool. And when you do an FMEA, oftentimes you do it with your internal group, your consultants, relevant stakeholders such as regulatory authorities, occasionally other interested parties. And it's a way to go through and discuss possible risks and come to an agreement over the likelihood, the environmental impact, the cost, the impact on human health, safety, etc. This is just an example. So when you're doing these type of FMEA analysis, you'll have multiple pages. And the reason why is when you start an FMEA, you usually look at a holistic question with regards to closure, like what is the impact of this closed mine on a recipient? And then you look at each of the individual components of that mining operation. For example, if you have a waste rock storage facility, an open pit, a tailings facility, and for each one of these portions of the mining facility, you're completing a risk analysis to look at how does any of these failure modes on this particular portion of the mine site affect the mine's ability to be able to close properly and not impact the environment or minimize the impact to the environment. So it runs like any standard risk analysis matrix with likelihood and consequence severity. And the idea is that you're bringing up these points that everyone at the table has a chance to suggest failure modes and to rate these failure modes accordingly. Just something to note that if we're doing an FMEA and we get a lot of red boxes, we need to start asking some questions. Are we all on the same page? We need to go back and look at the overall question that we've all come to agreement on. We need to discuss the time frame. Some of these things we'll be looking at in a short term, medium term, and long term, and then we need to define what those short term, medium term, and long term are in terms of years or time. Are we in agreement over what the probability means. Are we discussing about the chance of something happening 1 in 10 years, or are we talking about the chance of something that has happened within the last 10 years? And the consequence, and we need to really agree on what that consequence is. And if we're gone through all these things, we're still in agreement, and we land in a red box, that means we have to change something about the closure plan. Now, when you get these higher risk rankings during an FMEA process, it's really important that we record these risks and we discuss what type of mitigation strategies are available. Are they things that we need to increase our certainty with laboratory tests, field tests, modeling, studies, additional monitoring in order to manage risk or move the risk lower? You know, if we've gone out and done these things, let's say we've done some field tests, we've done some modeling, additional studies, have we actually reduced the risk? In other words, did we actually understand the risk correctly, and has that risk moved to a lower risk category? And now we'll move on to the more specific things. This is a quick image of the Kevitsa mine on the right-hand side of the screen, located about 180 kilometers north of Rovaniemi in northern Finland. It's a nickel, copper, platinum group element deposit, currently producing about 9.5 million tons per year. The major features include the tailings facility A, the large tailings facility B, which is a high sulfur tailings facility, the open pit, the waste rock storage facility, and some operational water ponds. A little bit difficult to see on these images are the recipients, the Matauraja Brook, the Kittilän River, Lake Salviari to the left of the screen, and groundwater, which is all around, and then the Nature 2000 area, which is in the bottom right-hand side of the screen. And as I spoke to earlier, the question should be holistic and integrate the elements domains across the mine site. Key interactions between individual domains affecting the closure performance. And examples might be, and this is not an example, this is literally the questions from Kevitsa. What is Kevitsa's water quality risk profile at closure in terms of the potential for adverse impacts to aquatic receptors downstream from the mine site? And then to demonstrate physical and chemical stability for all domains while optimizing risk and cost for Kevitsa, and ensuring the long-term stability from a physical, chemical, and biological perspective. When we did this process, it was a several iterative processes, and I'll show you in the next slide about how it worked out. These are the folks that were involved, not too much to say about here. So Boliden's Kevitsa staff, which was the managers from all of the different departments within Kevitsa, Boliden staff, experts internally in Boliden, and project leaders, technical experts, a field of consultants, and stakeholders at different points in time during the process. And this is basically how it worked. We start out with a knowledge base. So the preliminary closure design from Kevitsa, or the first accepted closure design from Kevitsa, that's our knowledge base. And then we develop conceptual models of the present conditions in the context of the closure goals. And at that point, we decided that we needed to do an FMEA to look and see what the group thought were the possible failure modes and what we needed to do to move this closure plan forward. And once we've done that, we've increased our knowledge base and we've done a design base case. So it's slightly different, slightly modifications from the original. Gone through the process of developing conceptual models, numerical models, testing different scenarios, and come out with a result. And that result, again, goes through an FMEA. We look for possible mitigation options and opportunities, increase the knowledge base through monitoring, field tests, cover programs, additional data. And one of the things you know is that with time, you're always going to have more data, so more data comes in. Modified the base case again, created another FMEA, increase the knowledge base, and continue this process all the way through to the closure. And again, just to bounce back to this, this is sort of one of those risks that we're looking at. which is a higher risk, and that has to do with stored load. And soon I'll leave this over to Stephen to talk about. But this was one of the actual ones from our FMEA process. Yeah, thank you. And this is one of those things that came out. So there it is, the stored load within the waste rock storage facility is significantly higher than predicted. The coverage system does not provide an adequate level of management for the stored load on the base of the waste rock storage facility. And some of these mitigation options were progressive rehabilitation, a waste rock characterization, opportunity for encapsulation, and undertaking field cover trial systems. Next slide, please. Yeah. And as we move through this, we started a lot of these simulations and investigations in order to look at the consequence and the possibilities to accelerate the cover placement, encapsulation of the waste rock, and perhaps change our design through time in order to move that risk down. And now I will leave it over to Stephen to talk about this in a little bit more detail.
Thanks, thanks, Seth. So I'm going to talk mainly about the risk to do with AMD, acid and metalliferous drainage. I'll use the term here. A huge amount of work, technical work's been done at the site, but it's too much to discuss everything. So I'll just talk to this. The reason, and even the use of the word AMD is important here, is that acid and metalliferous drainage is the term I prefer. The use of the word NAF requires very careful consideration. The reason is that metalliferous drainage occurs even at circumneutral pHs. So if you use the term NAF or non-acid forming, it doesn't necessarily mean it's low risk, and the use of the term PAF doesn't mean that you're communicating the level of risk correctly. Some material is potentially acid forming, but has relatively low risk of metal release because of low grade. Some material is non-acid forming, but can have higher risk. In the case of Kevitsa, it's an interesting mineralogy. It's an olivine peroxenite is the main rock. It's got low level sulfides, pyrrhotite mainly, but also has quite a lot of low levels carbonates, and being a olivine peroxenite also has olivine. So the silicates themselves are quite relatively fast weathering and provide buffering capacity. So there's a few things here with the interaction with AMD risk. One is that the carbonates, although they're relatively low concentration, they tend to fractionate to the fine fraction after mining because they're in veins. So they tend to shatter into the fine fraction, which means they're a very important pH buffering mechanism, hence the circumneutral system. The ultramafic silicates like olivine, serpentinite, they provide carbon sequestration potential, which is of topical interest now in the industry, but also they provide additional buffering. So the key point with this is that although the geology might seem relatively simple, that it's a non-acid generating system overall, so circumneutral, there are a lot of other things to consider for closure. So just touched on the carbon sequestration. So there's about 3 years worth now of research that Boliden have been leading here. Geochemic and myself at MEM have been working on. Essentially, been looking at there's two main things with these carbonation of these mineral silicates like olivine. One is that you can sequester carbon, so there's obvious carbon capture potential. But secondly, because the process of mineral carbonation produces carbonates, that means that you're also potentially mitigating AMD risks because you're generating carbonates and buffering capacity over time. So normally at a site, you just look at oxidation of sulfides over time, depleting carbonates, but on this particular site, potentially we're also generating carbonates over time. So it's an interesting concept. And where this may lead, ultimately for closure as an opportunity, is that typically waste facilities, once you mine them, they're viewed then as a liability. But actually, if waste materials can provide some positive contribution, like carbon sequestration, then in theory, you could consider some of the waste as an asset. So this is sort of viewing mine waste in a very different way, and quite in accordance with current industry focus on things like sustainability and ESG post-closure uses. The other thing to mention is site-specific testing. So just looking at the NAG test, for example, this is like a standard industry test used to determine AMD risk. However, it should be used in a very specific way. So on this site, because of the mineralogy, what we find is that once you do the boiling step on this NAG test, the pH goes up significantly, up to about 10 or so. Typically, people take the liquor from this test and they analyze it to look at metalliferous risk. But the higher the pH, the lower the metal solubility. So running the NAG test in the standard way, you can underestimate metal leaching. So at Kevitsa, we looked at this and ran a huge amount of tests without the boiling step, which is a modification of the test. And we can see here the pH, if you include the boiling step, the pH is like 9 to 10. Without it, it's 5 to 7. So by modifying the test in a site-specific way, meant we've better characterized the AMD risk. Second thing to look at is the approach for waste rock storage rehabilitation. So a typical design for waste rock storage facilities is to just dump the material and then at closure, place a cover on top and then think that that's going to solve the problem. But it can take decades to build the waste rock dump before the cover goes on. In that time, all of your weathering processes going on, sulfide oxidation is occurring, AMD stored load is increasing, which is identified in the FMEA as a key risk. And then once the closure's on, of course, then people think that's the end, nature takes over, and that's the mitigation done. But what we should look at is the opportunity that during the construction of the waste rock dump, if you've got a decade or so, you should really look at trying mitigating risk before you even get to closure. So during construction of waste rock dumps, generally speaking, oxygen ingress is unrestricted until you put a cover on there. Your waste material is absorbing water, so it's wetting up from a dry state. You're basically oxidizing sulfides, producing sulfates and releasing metals. You're depleting the carbonates, although potentially, like I said, on this site, maybe we're also generating some carbonates as well. And we've got like a net storage of AMD products during this process. And if this is occurring for a decade, that means by the time you get to closure, you're already building up a risk for yourself to deal with. At closure, once the cover system is on, then things start to improve because we can reduce oxygen ingress to a target criteria, reduce net percolation, and over time we'll have basically a net loss of AMD products because they're flushed out, and we have limited long-term sulfide oxidation. But that flush out time can take quite a long time, which is identified in the FMEA. So what was looked at here is what can be done during construction. So it's a little conceptual model just to show you what I've described. So basically during construction, we've got unrestricted oxygen ingress, unrestricted net percolation. All the reactions can occur in the waste pretty much as fast as they want to, and for as long as it takes to put the cover on. But most waste rock dumps are built in stages. Now, because they're built in stages, there's an opportunity to carry out progressive rehabilitation during the construction. And this is really key because if you can progressively cover a site, not only can you minimize AMD generation during construction, but it also means you can allow for unplanned closure, say early closure of the site, or changes to the design and the mine life over time. So during progressive and stage construction, in the surfaces, we still have oxygen ingress net percolation, but we can start to place low risk material on the outsides of each stage. We can build internal covers progressively as the waste rock's being constructed. This reduces oxygen ingress, and we can start to build the final covers on the outside at the same time. So overall, this reduces AMD generation. Then what that means at closure is that we have multi-stage closure. So now each stage, you can see here, this is 2 stages, they're closed independently. And then right at the end, you do have your final cover system, but it means that the overall, the AMD load is reduced during construction. So by the time you get to the closure, things are already a lot better than they would have been had you not done this. If we just look at this in plan view, you can see the brown is sort of the internal cover slopes, the green is the final, the blue is a final cover on the plateau area, the orange is like a high performance cover, which is placed on a selected area. So over time, we can see here that essentially as the waste rock dump's constructed, you can see the covers, internal covers, plateau covers have been placed progressively. So the whole waste rock dump is being closed progressively, and also this is in line with the life of mine plan for waste placement. So it's also a practical solution because it's tuned in with the mine plan. The final thing, which I'll also touch on here, which is can be done during construction, is to look at management of high-risk material. So as well as the bulk waste, most sites generally have a smaller volume of high-risk material. So in this case, there's it's less than 20% material, but it's a higher sulfur grade. Now this material can be placed in encapsulation cells using like a lower permeability material, a till, or perhaps reprocessed tailings. And this is done during waste placement again. This is quite flexible because the materials can be placed in small cells during construction, and it means you've got ongoing management of the highest risk material continuously. And because these can be closed off quite soon, it means the highest risk material is closed off basically first, and then the progressive closure means that all the rest of the material is then closed off still progressively. So overall, this is the main outcome from the FMEA was this strategy led to significantly lower AMD risks over the life of mine. So then at closure, you had a much lower AMD risk profile and improved water quality, long-term water quality objectives. So that's all we have time for. So I'll leave it there. So thank you to the organisers and to Seth for giving the first part of this presentation. And if you have any questions, then please let us know.
Thank you, Steve. Thank you very much. Yes, I do have a question. Steve, is landform design an aspect you have considered for reducing the risks for these long-term AMD?
Yeah, so Seth might want to talk to this as well, but yeah, landform design has also been a key part of this, mainly because at closure, I guess, like I showed my slide, the idea is that you have closure, the cover system goes on, and then all of a sudden, nature happens and everything's fine. But this has been considered in terms of surface water management and drainage. So if you place in a cover, you have to make sure, obviously, that if you're shedding water, that water then is managed, and also long-term vegetation. So if you place a cover system, do you want to consider if it's going to be populated by trees or grasses or bushes? Makes a huge difference. So yeah, landform design has been considered in terms of mainly surface water management, interaction with the cover system, and then long-term plans for I guess for revegetation, and ultimately what the end use of the site might be for. Seth may want to add something to this.
Yeah, do you wanna add something, Steve?
No, I mean I think Steve has pretty much covered a lot of it. It is a difficult aspect to use once you've already got the mine in production, especially if you're operating on a limited footprint. But it's definitely something that we're taking a serious look at.
Excellent. Thank you very much, both Steve and Seth, for these shared your knowledge. I understand that we have had some questions and comments in the chat, and so I'll turn over to my sidekick today, Annika.
Thank you, Emma. It's correct. We've had a number of questions from the audience, and I'll start with one for Seth. How is your experience from communication of these plans with stakeholders and others? Sort of, it's kind of a technical, high technology field, and stakeholders might be sort of non-technical experts on the subject.
Yeah, I can completely understand. When we have worked with the regulatory stakeholders, it even there took some time to get people ramped up and understanding the idea and able to participate. And then we have allowed Kevitsa themselves and to sort of share these results. It's a way to see that all sides are in on the discussion, and you can probably take a little bit different method. I wouldn't expect the average person to want to or to be able to sit through one of these meetings. They are pretty intense. However, you can see the results and you can see that we've worked on these things and that we've identified the risks. So at least in that way, you can get a feeling, if you're a non-technical person, that this is being addressed and it's being addressed in a serious fashion. So I can completely understand that it is technical, it's difficult, but at least we're being open with it. It's included in our documentation for permitting and closure processes. The conclusions are there. The discussions are also held in a less technical forum with different stakeholders.
Thank you. So, Hanna, do you have anything? Do you have an opinion on this work, this type of work? Is it common in Finland, or do you see this as a new way of working with closure?
Yeah, for sure. I think that Kevitsa is really showing the way. And as I said, that in order to make the social acceptance or gain social acceptance, we need to really focus on the risk-based continuous closure in the future more.
Yeah. I also have a question for you from the audience. Do you think you are making progress with the communication with stakeholders in Finland? Do you see that the companies are changing?
Well, at least I hope so. As I said, the atmosphere is quite, well, I don't know if I can use the word harsh on mining, but we can see it effects on legislation already also. So it really has an effect what sort of atmosphere the people are talking about mining and exploration. So I really do hope that with our communication and what the companies are doing, we can gain more acceptability.
Thank you. There are some more questions, but unfortunately not more time, so I will pass on those questions to the speakers after here. Thank you. Back to Emma.
Thank you.
Yeah, thank you very much, everyone, and thank you, Steve, Seth, and Hanna, for this first session. We're about to wrap things up now for this first session, and I guess we could use some of Hanna's word that social license is not a license that you can apply for; it's something to be earned. So, with these words, we will all head into a break. And we'll meet you at 2 o'clock again, 2 o'clock Stockholm time. Bye for now. Welcome back to the second session of today's seminar, Creating Value Through Closure. Now we are heading back to Finland, but this time to Kukkola or Karleby, to the Finnish Environment Institute. We will be listening to how environmental risk assessment could be used as a tool for decision making. Our next speaker has 20 years of experience from the field of contaminated land management and environmental risk assessment. So please welcome Jussi Reinikainen.
So thank you very much. Indeed, my name is Jussi Reinikainen. I come from the Finnish Environment Institute, which is part of our National Environmental Administration. And I will give you a short introduction to environmental risk assessment of chemicals. So the content of my presentation, first a short introductory to the regulatory risk assessment process itself. Then I will present some viewpoints on risk assessment using case examples that are mostly related to regulatory threshold values often applied in risk-based decision-making, including mining areas, although the focus of my presentation will not be on mining per se. And finally, I'll have a short summary on the topic. So, there are two main types of environmental risk assessment in the regulatory context. Prospective risk assessment that aims at prevention of new environmental contamination and risks, and prospective risk assessment aiming at the management of existing contamination risks. They are both based on the same generic principles, but their objectives and approaches may vary. So as regards mining activities, for example, prospective risk assessment applies to operative practice and its planning, while retrospective risk assessment considers the post-operative practice after the mining has been closed. Risk assessment is both a scientific procedure and a regulatory decision support tool aiming at answering the question whether chemical risks are significant enough to require some kind of management actions, and when they are, to what extent. Risk assessment is always based on a source pathway receptor linkage and the conceptual site model built up using the actual site information. This linkage, it's always case specific, and it usually needs to consider both environmental and health aspects. Tiered approach in the regular risk assessment is usually applied, meaning that you may start with simple screening type of analysis, providing rather conservative risk estimates, and when necessary, move into more detailed assessment while providing more realistic estimates. The projection goals and the actual contents of risk assessment always depend both on the case in question and the regulatory demands. So if you remove or sufficiently manage the source pathway or the receptor, there is in principle no risk. However, in the environmental risk assessment of chemicals, the risk is hardly ever totally zero, but it can be insignificant and acceptable if the exposure and effects can be considered small enough. So here's an example of a conceptual site model from an old mining site. At these types of sites, you usually have several potential sources, pathways, and receptors you may need to consider. The idea of the outlined or actual risk assessment then is to identify the most relevant risks on the site and to target the actual assessment on those. So most often, at least on old metal mines, the most relevant sources include tailings and waste rocks that may get oxidized and produce acidic and metal-contained leachate into the environment. And the main pathways in this case is most often, well, at least in the Finnish case, concern surface runoff in ditches and streams in the area. And so the risk assessment should then be able to provide reliable estimates of the contaminant mass fluxes within those water courses. So taking into account both the contaminant concentrations and flow rates, as well as the seasonal variation, for example. And here the systematic planning of the site investigation plays always a very important role. The most relevant recipients in such case typically is to receive the surface water bodies down gradient of the site into which the surface runoff discharges. And the most important risk then concern the aquatic ecosystem. So if the risk, if you evaluate the risks to the aquatic ecosystem in this case, for example, were to be unacceptable, some risk management actions targeted at the source or the pathways would be needed. For example, by reducing the oxidation of the waste or the leachate production at the waste sites, or by treating the surface runoff. Reference values, well, reference values, thresholds, they have many names, are commonly used tools to regulate environmental contamination and waste. These values are very often the focus of discussion when it comes to risk assessment, although they are or should only be tools in the assessment process, and quite often they are even misused. So that's why I wanted to focus my presentation today on these values. So the thresholds are usually risk-based values considering contaminant concentrations, emissions, or intakes defined in theoretical environmental conditions and exposure settings. However, it's important to know that in addition to toxicological aspects, these values may also include political or socio-economic elements. And some values, on the other hand, are not based on exposure-based assessment at all, but only on the intrinsic properties of the chemicals. Example of this being the concentration limits for hazardous waste, for example. Moreover, it's very important to understand the regulatory objectives of these values and how they should be used in their original regulatory contexts. They may, for example, be theoretical long-term quality objectives, values triggering further investigations or assessments, or in some cases, cutoff values for risk reduction, but certainly not always the latter. So not all the values indicate non-acceptable risks. It is also important to consider if these values are designed to be used in prospective or retrospective risk assessment, or both, because prospective risk assessment usually is more strict in terms of risk acceptabilities than retrospective assessment, for example. And different values include different protection targets, represent different protection levels, and they are applied at different spatial and temporal scales, and they may not be legally binding at all, although presented in regulations. We have some examples of that, and they may not apply to historical contamination, may not directly even obligate operators, but authorities and so forth. So my main point here, nevertheless, is that understanding the premises of these values, including both their foundation and application principles in the regulatory context, it's very important when using them in risk assessment or in any other decision-making purposes for that matter. So first, I have an example of ecological risk assessment on an old mining site from Finland. Long-term average cadmium concentration in the SveMin lake here was about 0.8 micrograms per liter, and the main concern in the area had been the exceedance of the annual average environmental quality standard, EQS, being 10 times lower than the concentration in the lake. However, according to species sensitivity distributions based on the available toxicity data, we used potentially effective fraction of the aquatic species in the lake in the measured, or with regard the measured concentration was estimated to be around 9%, indicating all low, maybe to moderate risk. It's also worth noticing here that the EQS is actually well below any toxicity test result within the database, as you can see in the illustration. And hence, it's likely a very conservative estimate of no effect at all type of concentration in a real-world situation. And because of this, it also should not be the primary value to be used when defining acceptable risks as regards historical mining site. Concentration of zinc, on the other hand, in the same lake was around 420 micrograms per liter. And there's no EQS or similar official regulatory values for zinc in surface water in Finland, which is likely why zinc hadn't caused as much concern as cadmium prior to our assessment project. The same approach, using relevant toxicity data, nevertheless indicated effects on more than 90% of the species in the lake, and even the bioavailability corrective concentration exceeded the corresponding calculated bioavailable EQS by 20 times. On the other hand, despite this high risk based on the chemical assessment, biological surveys carried out at the lake did not indicate as severe effects in the ecosystem, at least relating to the present day emissions. So chemical concentrations and concentration thresholds are definitely not the only way to evaluate risk in this cases. In addition, lots of previous studies during the last couple of decades had been done in the area in which the main source of metal emissions and contamination in the environment was assumed to be related to the tailings. However, in our site-specific risk assessment, including catchment area modeling with relevant mass bulk estimates, showed that 90% of the present emissions to the lake at least were in fact coming from the waste rock piles, leaving the contribution of tailings below 10%. So as a conclusion from this example, in this type of historical cases, site-specific risk assessment with the systematic, well-planned approach by using multiple lines of evidence is always very important. It's also good to understand that the regulatory values, such as the EQSs, are not necessary or should not be the main risk drivers on such sites. So here's another example of existing EU thresholds, in this case, PFOS. In the Water Framework Directive, EQSs for PFOS in surface water have been given. The EQS biota being 9.1 micrograms per kilogram of fish, and the annual average EQS in surface water being as low as 0.65 nanograms per liter. The European Food Safety Authority, on the other hand, has set a health-based intake value for PFOS, which is 150 nanograms per kilogram of body weight per day. And this value actually has been used to derive the current EQSs in surface water by assuming the following default factors for bioaccumulation in the water and fish consumption, meaning thus that the EQS values for PFOS are actually risk-based, health risk-based. In 2018, EFSA revised its TDI value for PFOS and came up with a new value more than 80 times lower than the previous one. So should the regulatory decision making in the EU be consistent, the EQSs would surely be modified accordingly using the EFSA's new value, which would end up in EQSs way below the normal background concentrations. And even if, well, this is not enough, EFSA updated once more its value in 2020, giving now a group value for PFAS compounds, and based on which the EQS for PFOS would get even lower. So my take-home message from this example goes that the regulatory objectives and the derivation basis of the thresholds should always be considered carefully when applying them in case-specific risk assessments and decision making. And this also applies to the derivation of new regulatory values or the revision of the existing values, as was explained by this example. And last, one example from the typical and rather mindless, if I may say, application of soil guideline values from Finland, where these values are not legally binding, but only indicative tools in the site-specific risk assessment, which, on the other hand, is compulsory based on legislation. So, local soil ecosystem is often not the primary protection goal in Finland. In these type of cases, unlike health risks, and still the soil ecotoxicity-based soil guideline values are used often rather straightforwardly as remediation criteria in these sites. For example, the lower guideline values for zinc and copper, which are one of the most typical contaminants in soil, are orders of magnitude lower than the health-based values. Moreover, well, soil excavation or dig and dump, if you will, is still the most common remedial solution. So, that being the case, one really has to ask if this practice follows actually the risk-based approach at all, and does it even protect the local soil ecosystem? So, summing it all up, I think developing a sound conceptual site model is the key in every risk assessment. This includes the identification of relevant source pathway receptor linkages and refining the model by new information during the assessment. Just as important is to set very clear objectives for each stage in the assessment process, including detailed investigations, exposure and effect evaluations, and so forth. So when doing the actual assessment work, such as evaluating the contaminant migration and exposure, it's also crucial to use appropriate methods and preferably multiple lines of evidence in order to increase the reliability of the assessment, and paying a special attention to representative sampling in retrospective risk assessments. And last but not least, my suggestion always is, well, please try to avoid putting too much emphasis on these generic concentration thresholds whenever that is possible in your regulatory contexts. Because the truth is that those generic concentration values can never replace a proper site-specific risk assessment. And if or when such values will be used anyway, because that's usually the case, make sure at least that you use them correctly by considering both their derivation basis and their regulatory objectives and purposes. So, as my final remark here, a systematic and well-planned and implemented risk assessment is really a precondition for justified decision-making and reasonable risk management actions independent of the regulatory context, as long as it deals with environmental risks of chemicals. So this applies to both prospective and retrospective assessment in every industry with potential to environmental contamination, including mining. So thank you very, very much for your attention.
Thank you, Jussi, for your presentation. I was wondering, do you see that the current regulatory frameworks, do they sufficiently promote using this risk assessment in environmental decision making?
Well, I would say that many regulatory frameworks, well, at least they do include a lot of risk-related elements, and some even require risk assessment specifically. But sometimes it seems that maybe the basic principles of risk assessment, like the fact that the risk assessment should always be based on actual site-specific considerations, do not necessarily reflect clear enough in the regulations. And well, I also, like I mentioned in my presentation, in my opinion, the role of the generic concentrative values in those regulatory frameworks is often highlighted maybe a bit too much, and sometimes not enough attention, on the other hand, has been placed on their appropriate application. And I think that this easily leads to their misuse, as well as I explain something in one of my examples there. And also, I think the interlinkages between different regulatory frameworks or the specific objectives are not always clearly defined, and risk assessment approaches or the regulatory values are being adopted from one context to another, sometimes without proper justifications. And this may sometimes lead to management actions, I think, that are not necessarily needed or proportional compared with the benefits of the actions.
Okay. And how does this environmental risk assessment apply to active mines?
Well, I think they do well, because I think risk assessment really it's needed in all the industries, permit processes or other decision-making purposes, wherever chemicals are being used, waste or are being disposed or reused, or wastewaters are being produced, whenever these chemicals or wastewaters may end up into the environment. So in mining, well, environmental risks need to, of course, be considered at all the stages of the mine's life cycle, regarding the mine's planning, its whole operational phase, and finally, of course, the site closure and any necessary follow-up measures such as the monitoring. The focus objectives of risk assessment at these different stages may, of course, vary, but the same generic principles of risk assessment do apply to all of them. So including the source pathway receptor linkages, for example, and the conceptual site models, evaluation of the emissions to the and the associated effects. Yeah, but like in any other decision-making purposes or circumstances, I think that it's also very important to understand the linkage between the risk assessment and risk management. They should really be properly considered in advance, taking also the economic and social aspects into account too, as we've heard already before in the previous presentations.
Thank you again, Jussi, for your wise thoughts that you shared with us. Do you as viewers have any questions or comments on his presentation? Please let us know. Again, use the chat box and post questions directly to Jussi, and we will try to answer them at the end of this session. And you could, for example, compare, should this method be used? How are these environmental risk assessment used in your country? Could we learn something from each other, from in between nations? I liked also that he said that risk is hardly ever zero. And I guess that goes for life in general. Anyway, now I'm handing over to one of the organizers of today's seminar, Matt Baida. And Matt is a landscape architect and a co-founder of VAST, a company specializing in geomorphic design. And he will be presenting the story of geomorphic design using the presentation technique Pecha Kucha. Correct me if I'm wrong in my pronunciation, but if you missed your Japanese class back in school, I can translate this into chit chat. So I've been told anyway. Pecha Kucha, this presentation technique is a 20 by 20 presentation format, and is that you show 20 images, each for 20 seconds. In other words, you've got 400 seconds to tell your story with visuals guiding your way. And Matt said to me that if you can't say it in 400 seconds, there is too much hot air. So let's give the floor to Matt Baida.
Awesome. Thanks, Emma. I'll put myself in a bit of a rock and a hard place here, so I have to try and limit myself to my 400 seconds. So thanks for the introduction. And as Emma mentioned, I'll be looking at geomorphic design, the Swedish story through Pecha Kucha. So let's get stuck into it. So 2017, a question, Matt, can you design a waste rock dump that channels water to nitrate fixing bioreactors as part of the STRIM project? So my answer was, of course, yes, but in reality was actually, oh shit, how am I going to do this? I spent a year and a half then worrying about what I was going to do and how this actually would eventuate until my light bulb moment. Geomorphic reclamation. I had a tip from a colleague about a landform design course in Spain. So I was on the next plane to Madrid, where I was learning from the world's best practitioners and researchers about the concepts and implementation of geomorphic reclamation. So this was a welcome sense of relief and also excitement. So what did I learn, and what actually is the fundamentals of geomorphic designing? Essentially, the main goal is to create a natural landform which is long-term stable. And this is achieved through controlling surface water through a designed channel network on the surface of the landform, which in turn minimizes erosion. So essentially we are compressing time, and we were designing just as nature would have done it, except we don't need to wait 10,000 years for this to happen. So water will erode a natural landform until there's enough drainage on the surface to not cause any erosion. And this is what we call a landform that has reached hydrologic balance. And this is what we create. So this design channel network consists of swales, ridges, and valleys. And these are important, not only controlling the water and conveying the water from the surface, but also create a complex surface, a complex landform, which consists of different aspects, different gradients, different moisture retention areas, which is all great stuff for vegetation establishment and biodiversity, as it creates different ecological niches on the surface of the landform. So I was convinced this was enough for me, and I think this is the approach that was needed for the STRIM project. So I was back on a plane, back to Sweden, freezing old Sweden, to spread the word. I think it was time for a paradigm shift in the approach to waste management, looking at a new alternative that looked to work with nature, not fight against it. So the STRIM project, from a geomorphic perspective, was important as it was a process of education We did develop a conceptual design for the project, but more importantly was the introduction of the method and the principles of geomorphic reclamation to the Swedish mining industry. Also, from a personal point, the project was very important as I'm now a partner of a company called Vast Design, which we team up with the best in the world to implement geomorphic design and reclamation, and we love doing what we do. So when we say working with nature, it does mean a more complex design process because you need to understand how your landform connects aesthetically, but also more importantly, functionally with the surrounding landscape. So it's not as simple as just placing your waste material as close as your operational area as possible to minimize cost. But this complexity is actually a good thing because more questions are asked and need to be resolved during the design process from different experts involved. So it actually contributes a lot to risk-informed closure design. So we're teaming up currently with LKAB at their Kiruna site up in northern Sweden, where we have been looking at a geomorphic approach for their site up in northern Sweden. So we're looking at using the approach to cover their deformation area and also tie in with their closure goal, which is looking to reflood the open pit lake at closure. So we're not only helping them with their environmental goals, but we're also helping kids all over the world as they get their Christmas presents delivered on time. We can create landscapes that have landscape features such as plateaus for grazing, and also ridges and valleys, which can be used as wind protection. So we recreate landforms that are beneficial for reindeers, but not like this, perhaps something a bit more like this. So if we can use a legacy, if we can leave legacies such as this, why wouldn't we want to explore different approaches to land waste management? So this is an outcome from the Nitram project. It's a visualization we did looking at integration of LKAB's landscape vision and our geomorphic design approach. So ongoing discussions within the mining industry, community acceptance, and also land use opportunities. So this approach ticks both of those boxes. So a key component of geomorphic designing is taking landscape feature measurements from a local and stable reference site. And these landscape measurements are then put into your design work. So this means what we create through our design and the landform, it should function like the stable landform and natural landform that we take the measurements from. So after several expeditions up to northern Sweden, this work is ongoing for us. We know it is a complex landform, but we are developing a better sense of how to recreate these landforms. So we are using this knowledge of the local landscape and the measurements that we've been taking from these expeditions, again, teaming up with LKAB, but this time at their Svappavaara mine site. This is a 280 hectare site, 100 million tonnes approximately of waste rock. We've developed a geomorphic approach, which is looked to integrate their existing built waste rock dumps with this new idea. So excitingly, this has led to the approval of a 4 hectare test site, which I believe will be the first in Scandinavia and is currently under construction. So through this test site, we'll be monitoring water quality, stability and vegetation establishment in the coming years. And this will be all used to develop our knowledge and improve our designs in the coming phases. So this site is not just about creating the perfect test site, but more importantly about testing the idea here in Scandinavia and adapting our approach as we gain knowledge through the monitoring. It is also about continuing the education that is needed around geomorphic design. So we need to rethink the old ways and educate on new alternatives. By planning the beginning from the end and knowing where and when you need to place your waste rock, how you're going to connect with the surrounding landscape and what your final landscape vision or function should be, it is not only geomorphic designing is not only playing a key role in maintaining a license to operate, but it's also proving to play a key role in gaining and obtaining a license to operate. Last week, while visiting a mine site in Spain, the head of the mines was explaining that this mining company had submitted a permit with a geomorphic approach as its base. So based on that, the permit was approved, given the beneficial outcomes from a geomorphic design. So this was a €200,000 investment, which sees the mining company continuing operations for the next 5 to 10 years. So I'd say this is a good return on their investment. Vast is currently teaming up with Copperstone as they are moving through their environmental permit application. So we're exploring the idea of a geomorphic approach for their sites. If successful, I believe this will be the largest site in Europe where they have adopted and look to implement a geomorphic approach from the beginning of operations. So as for Vast, we're currently back in Madrid, where it all began, striving for better geomorphic outcomes. For us, geomorphic designing is not rocket science, but more common sense. Instead of fighting against natural forces with engineering solutions, we're looking to work with nature for better outcomes. So there is a more considered design and planning approach needed for geomorphic designing, but essentially it is just about thinking about the end from the beginning. Otherwise, it is just dumping dirt and pushing it around as usual. So thank you. I think hopefully stuck within my time.
400 seconds later.
Maybe just.
Thank you, Matt. Thank you very much. We are all the examples that you mentioned, they deal with vast, pieces of rock. Vast amounts, huge amounts. So how much more does this cost to rehabilitate an old mine site in the way that you are planning than having it the way that we usually have it these days, very engineered, squared shaped?
Definitely. Very fair question, one that comes up quite a lot. And I think Seth made a good point in his response about Boliden looking at a landform approach for their site as well. And in theory, if you are planning the end from the beginning and you're implementing a geomorphic approach from the beginning, then it should cost the same as it would your conventional approach, what I'll call conventional approach, these traditional ways of waste rock management. You are moving the same amount of material, you're putting it in a location on your site, and you do some final grading of that surface. There's a little bit more training needed for the machine operators, but in reality, it's only a couple of weeks. So if it's done from the beginning, it should cost the same. But if you're trying to retrofit an existing waste rock dump where you have to move some of the material again, it's going to cost you more because you've really placed it there, which is an expense, and then you're rehandling it essentially. So that's sort of the direct cost analysis of it, I guess, simply. But you've also got no ongoing, or you minimize or eliminate ongoing maintenance with a stable landform, the potential to gain a permit, social acceptance, your social license to operate. So there's a lot of indirect costs that can come from such an approach as well, which I think need to be considered, not just your build costs.
I was thinking about another aspect as well, that we also from the LKAB, they have this huge project, REMAP project, where they're mining their old tailings or waste rock dumps. Do they, in what aspect, you spend all this time, constructing, making this geomorphic design of waste rocks, and then you might, maybe you need to get access to these hill or whatever in the future. Isn't it more difficult to do that if you have spent so much time designing it and it's not square shaped?
A very good point. And that's looking into the crystal ball a little bit. And I guess that question, from my perspective, geomorphic designing, you can implement it progressively. So if you do some of this early stage analysis and you find that some of the material and the waste rock that you think you might want to have a look at a little bit later as technology improves, or you need to get access to it again, you can plan your waste rock dump in a way that places that material in somewhere that will be accessible in the future, where some of your more like your waste rock that you know you're not going to use again, maybe you can place that in the center a little bit more. So you could be a bit clever with the logistics of your placement of the waste rock, and you can implement it progressively. So maybe you use the waste rock that you're looking to potentially reprocess later in the process. But it's, yeah, as we know, sometimes if they need to go back into things in these old dumps or tailings, then it's going to be an expense, and that's based on a cost analysis that it's worth reprocessing some of that material. And if the cost of the geomorphic design, if you do it from the beginning, wasn't any more than a conventional approach, well, then I guess a little bit more time is spent designing these things. But if it's an expense they think is worth it, they might just have to tear up our nice looking nature. But that would be a conversation I'd like to have and suggest, mate, is it worth that? Or is it worth just leaving the natural environment to return? But a tricky question, definitely.
It definitely is. So thank you very much, Matt Baida. Do you as viewers have any questions for Matt? Do you want him to clarify something, or do you want him to sort of elaborate on something? Please let us know. Use the chat box that we've been talking about, you know, fill in your questions on that side. Now we're changing topic. Mining has been an important part in the making of the modern state of Sweden. For example, the mining area of Garpenberg, today owned by Boliden, mining dates back to the year 400 BC. 400 BC, it's unbelievable, but that's true. We have many old mines all over Sweden, and mining closure, it's not only technical that we learned today, the social dimension has to be taken care of too. So how closely connected to the cultural heritage of a village or a city are the landmarks of a closed mine? And what should be saved for generations to come? Our next two speakers are developing a new research project aiming to explore under which circumstances cultural heritage processes can contribute to the creation of new values after the end of mining here in Arctic Sweden. And they have been focusing on a case study of the former mining settlement of Laisvall. So please welcome Professor Dag Avango and Malin Brännström.
Thank you. I think we have some sound intervention somehow. Maybe you can fix that. Thank you. Thank you. We will present results from a research program about the role of cultural heritage after mine closures, and a new project on this theme that is in the making. And the research has been made within the framework of a center of excellence called REXAC, Resource Extraction and Sustainable Arctic Communities, which involves 15 universities in the Nordic countries and is funded by Nordforsk going into the final months now in 2021. The aim of REXAC has been to understand the relations between global processes of change, climate change, resource demands, and so on, and Arctic communities with a focus on the extractive industries. And we have explored how to explain booms and busts in the extractive industries in the Arctic in a long-term perspective, and what the consequences of extractive industries have been for communities and environments, and how extraction-based regions can transition after extraction. And this last mentioned theme has somewhat focused on the role of material remains from mining in transitions to post-extraction. And we have been working here with the main question under which circumstances that legacies from mining can gain new values, and for whom and for what reasons. And we have been looking at different post-extraction mining futures and the role of material legacies in them, looking at abandonment, many cases of mines just being abandoned and decaying, particularly older mines. Environmental remediation, of course, which many of you are working on, but also on re-economization and on heritage processes, which are concepts that I will get to in a moment. And the idea of making heritage out of mines is, of course, not a new idea. It's a global phenomenon. You have many examples of World Heritage sites, for instance, that are built around legacies from mining, like the tin mines in Cornwall, like the Meiji Industrial Revolution sites from Japan with this coal mining island that you may have seen in some James Bond movie recently, or large industrial districts involving mining like Nord-Pas-de-Calais in northern France, or indeed the Falu copper mines that you know of from southern Sweden and the entire region of Bergslagen, the older mining district of Sweden, where many of the abandoned and closed mining sites today are reused as cultural heritage purposes. And we have moved this thinking of mines as heritage into the Arctic region. We have been looking at different geographies and mines from different time periods, part of them in the Swedish north, of course, Västerbotten and Norrbotten counties. Some of them from Greenland, where you have had mining from the 1850s up until the present. We'll be looking there at copper mines, at cryolite mines like Ivitut, but also uranium and coal. Svalbard is a mining region in the Arctic we have looked at quite a bit, where you have coal mining from the early 20th century until the present, and also the northern parts of Canada with Quebec and Labrador, where you have iron ore mines, historic and present. And so the different processes we have been looking at is, one of them is re-economization, which means basically creating new economic activities in built environments and landscapes that remains from mining, often by repurposing with value-making activities such as scrap metal for producing new steel, which is the what has happened at many mining sites across the Arctic, but also repurposing of mines and mining towns into research stations, where Ny-Ålesund is a well-known examples. The building of tourism economies around historic mining sites. This is from Malmberget in Sweden. You have many examples across, and also a wide variety of other forms of repurposing that exists. And what we have seen is that actors in Arctic communities have tended to find rather innovative ways of ascribing new values to abandoned systems for resource extraction. And some of those are connected then to the practice of turning material remains from mining activities into cultural heritage. And there are different ways of doing that, different heritage processes, as we call them. One is the practice of official heritage making, that is remains from mining that are defined as cultural heritage by heritage expertise and protected by states through state organizations and through law and regulations. And this official heritage making has in the Arctic region had different goals, but typically they will be about supporting natural cultural policy goals, supporting local identity and local quality of living, and also to support heritage tourism. And in some cases, also to exercise sovereignty, particularly on Svalbard, where historical legitimacy is important to both Norwegian and Russian actors. Another form of heritage making is what we call corporate heritage processes, where older remains from mining activities are defined as heritage by companies and protected through the fact that they own the remains and have the financial muscles to protect them and save them. But the goals are typically different. It can be about building trust towards customers or building local legitimacy, goodwill, SLO, as has been mentioned here before, but also to influence public opinion on matters pertaining to future mining operations. Another form of heritage making is what we called unofficial heritage making, and that is the definition of remains from mining as heritage by local actors for instance, homestead societies or local enthusiast community groups of different sorts. And they don't have the legal means to protect things, but rather voluntary work, voluntary management, and also voluntary ways of narrating the history of places. And their goals are sometimes overlapping with official heritage makers and corporate. That is to support local identity. It can be about creating a resource for collective and individual memory and thereby quality of living. It can be resources for local businesses, typically around tourism or tourist-related activities, but also a resource for political mobilization when legacies from controversial past operations are used to push for political goals, like in this case from Kutliset in Greenland, mining town that has been figuring much in the debate about the future autonomy or larger autonomy or independence for Greenland. And some of the conclusions then from our research on this field is that planning and governing the afterlife of mines require consideration of a wider variety of post-extraction future, the ones that involve the potential for reusing legacies of mining through re-economization and through heritage making. And we have also seen that successful value creation through heritage processes requires influence in the planning and execution of mine closures from local communities and also to some extent from heritage expertise. And of course, more favorable institutional and economic conditions for doing so. And building on these conclusions, we are now formulating a new research project that is in the making, which I invite my colleague Malin Brännström and co-presenter to speak about. Malin.
Thank you. Yes, so I'm a researcher in law working at the museum, a local place, Silvermuseet in Arjeplog. And this is an area with a lot of mining history with Nasafjäll, Silbojak, Plautajak, and also Laisvall. And I've also worked a lot with with mining and forestry and the conflicts of interest with reindeer herding. So in a discussion within this project and also in a discussion with Boliden, we started to discuss the local aspects of these processes going on and the long time perspectives that you have when you live in an area, and also the relations between the humans and the landscapes where the mines where mining is taking place. And what we see now is that in this area of Laisvall, we have a lot of people still living in the area close to this mine that is now, it's 20 years this weekend since it was closed. So it's been 20 years, but we still have a lot of people living there with relations to the landscapes. We also have 2 reindeer herding communities in this area, around this area, and Boliden is planning and has worked a lot with how can we work with old mines and develop these areas. So what we're trying to do here in this project and what we're planning to do is that cultural heritage and dialogue processes could be an aspect to really come to a discussion about how can these areas be used in the afterlife of the mine. So we are planning to deal with these things together with the people living in the area and with these different aspects that we've learned from the REXEC project. And our aim is to develop a new method for post-extraction value creation through these types of heritage processes. And the research questions that we are now forming out is that how should heritage values be identified in an environmental transformed by mining, and how can mine closure processes be designed to meet the desires and the future visions of local communities. And what we think is really to have this type of licenses, this social acceptance, is also to relate to the people that will be living in the area afterwards, and also show the responsibilities to have a relation with these groups. So this is what we want to do. And with my local perspective and with Dag's experience from these types of processes from other parts of the world, and with Boliden's engagement in these issues, we think that this is really a new way of dealing with old mine sites that also can lead to new thoughts. How can we develop the process with the afterlives of the mines? And I don't know, Dag, if you want to add something to that short presentation of our project.
No, thank you. Excellent.
Okay,
I think
so yep.
we're done.
Thank you for your attention.
Right on time, then. Excellent. We're sticking to our schedule. I was just curious about one thing. Do you believe that the mining companies take enough responsibility in this aspect?
I think more can be done. Of course, I think there's an ongoing discussion about mining that leads to thoughts that maybe the mining industry needs to explain more and take more responsibility. So I think there are development that can be done in this area.
What do you say, Dag? Do they could they be more responsible, or in that case, how?
Well, I think there's a big focus on in the discussion about environmental remediation, focusing on how can we harness and deal with toxic legacies, while there is too little attention to the built environments and remains that can actually be used for something new. So this way of combining, having two thoughts in the head at the same time. What do we need to take away and what can we actually keep? And I think I'm thinking of Matti's presentation here previously. I think it's of course fantastic when you can create new landforms looking at the environment. But before doing that, I think it is important to consider what are the heritage values that have been generated from a period of 130 years of mining here, that does not necessarily destroy the environment, but that can actually be, that are regarded by people as an important part of their local environment, that has some value, and which parts do we need to get rid of because it's harmful for their environment and not desirable by people living in the area. So having these two thoughts in the head at the same time, heritage as a value way of making values, and environmental remediation also they can be combined. I'm convinced.
And I believe we have a very accurate example in what's happening right now in Kiruna when LKB is sort of moving the town. You know, they were thinking about these aspects, you know, way before they even started to tear down the first houses, you know, documenting the people who live there, collecting stories, publishing books and everything. All these things going on, small and big. So I think that's a very, but again, how do we select what should be kept?
Well, I think this is where it is so important what Malin just spoke about, that you need to have a discussion and to have influence from the people who will remain living in the vicinity of the material legacies that remains from mining. The transformed landscapes, the built environments, you need to have a dialogue with them to find out what their opinion is, because they will remain there while the company will eventually leave and go somewhere else. So I think that's an important aspect of the new project that we want to do also, how to develop a process where you can get the points of view from local communities and make them create a possibility for them to influence post-extraction.
Yeah. So Malin, when will we have a result from your project?
Well, we're hoping to get finance for this project, so that's the first part of it. But we've already started to, Dag carried out some interviews, really interesting in people talking about how proud they are of the mine, but also the things that they have been criticizing, and we're getting new thoughts about how to do this. So we're actually we'll try to start the project this upcoming year.
Excellent. Thank you very much, both of you. Thank you.
Thank you.
Now we will head into the next short little break, and we will meet you back here on screen at 3 o'clock again. So in 5 minutes. So see you in 5 minutes at 3 o'clock. Bye bye for now. Welcome back to this third session of today's seminar on creating value through closure. Having a perspective of 1,000 years when reconstructing an old mining site surely comes with some clear challenges. How should it be designed to withstand weather, wind, erosion, and climate changes? And what long-lasting materials should best be used? Our next speaker is a mine closure specialist with Golder Associates in Canada, in Vancouver. Her work is focused on the design of tailings and waste rock landforms for closure, and the use of landscape evolution models to test these designs. Let's get wiser together with Nilcha Slingeland.
Thanks very much, and thank you so much for having me here and sharing your afternoon. So as mentioned, I'm going to talk about geomorphic design, give you a quick background, and discuss how it relates to risk management. So in an ideal situation, geomorphic design generates a system at equilibrium like this one. So ideally, geomorphic design provides layers of defense or layers of redundancy and a dynamic solution that responds and adapts to environmental changes. So those could be changes in precipitation, in climate, forest cover, etc. So it responds and adapts to these without external intervention. Now, this natural system that's shown here has very steep slopes and very shallow slopes. It has ridges and swales, and it's not without slope failures or erosion, but they are managed locally and recovered from naturally. So given that a systematic and structured approach is taken during design, a landform design based in geomorphic principles can have similar performance outcomes and is an effective method of managing risk associated with mine waste structures and future landforms. Geomorphic design has historically used natural analog landforms as a basis for design. Using natural analogs involves first identifying one or more landforms in the same region and elevation, and composed of similar materials to those that you intend to design with. Next, the analog landforms are quantitatively characterized. So I'll go through just a few of those ways that we characterize these. We looked at several different quantifying elements, one of them being the catchment area and associated slope gradient at the point that you're measuring that. We measure the overland flow path. And I can go into these more in detail if anyone has any questions. For now, I'll breeze through. Hill slope gradient and position. And the intent of this is to identify a range of various slopes that create these associated profiles with an area. And undulations as well. So many landscapes that don't have distinct watershed boundaries, as we saw in the previous slides, have these natural undulations. So if this is a contour, they kind of weave back and forth and have an associated amplitude and length associated with them. So you can see this in nature. This is just an image off of Google Earth. And these are forestry roads that run at fairly shallow slope. And you can see they kind of weave back and forth in the landscape naturally. So these are the things that we measure, many other as well, but just an overview of some of the things we measure in order to start to characterize our landscapes. Now, the characteristics of the natural analog are then applied to the area to be designed. So for example, the slopes in the background on this image may be characterized so that those metrics can then be applied to the slopes in the foreground at closure. A geomorphic design has been historically a tough sell in the mining industry for a variety of reasons. First, there is substantial uncertainty regarding the mine lifespan, but beyond the logistics, mining produces vastly different materials from undisturbed soils. Mine waste may be finer or coarser, it could be more angular, more rounded, could be chemically altered from the natural soils. And all of this means that the materials will in turn behave differently from natural soils that the natural analogs are containing. So for example, right now I'm working on a project in BC in Canada, and my natural analog at a similar elevation and similar grain size distribution has slopes roughly of 60% gradient. On the site that I'm working on, same elevation, same grain size distribution, on a 45-degree slope, we're seeing 2 to 5 meter deep gullies. So designing a slope at 60% gradient in mine waste, even though that is what the strict natural analog approach would dictate, would be entirely unsuccessful in this particular case. Now, additionally, mine waste structures tend to have a high consequence if failure were to occur. Mining landforms cover enormous areas of land, and even a small amount of maintenance across the entire structure can have very large costs adding up. Additionally, dam failures and spoil failures have cost lives and continue to do so. These can therefore be quite delicate structures, so we really need to get them right. So for these and other reasons, engineers have been more comfortable designing engineered structures and continually maintaining them rather than using the geomorphic approach and quote unquote putting their faith in nature. A method that I've been championing for the last few years is the use of landscape evolution models. Landscape evolution models, or LEMs, allow for climate and material properties for a site to be directly input to the model, such that short and long-term erosion and deposition of that soil and landform is simulated in 3 dimensions. These can run for a single storm event or for 10,000 years and over. The results predict hydrologic and geomorphic performance of a specific landform according to actual site-specific properties. And this can help to identify long-term stable forms accordingly. So including this additional step in our design process allows us to use the best available information and in turn the best available technology as well to guide geomorphic landform design. So what you're looking at here is a mine site with a pit shown in blue and waste rock dumps that have gone through this process. So the top image shows the existing conditions prior to design and construction. The waste rock dump in the north here has been partially constructed already with a geomorphic design on the northwest and an elongated and regraded platform bench slope here. So you can see this is at a constant slope that's much lower. The entire south waste rock dump has been unchanged from operational conditions. The lower right image shows the final design using the characteristics from natural analogs, as well as adjustment following landscape evolution modeling. So a few things jump out at me when I look at this design in particular. The geomorphic design covers pretty much the same footprint as the operational design, while the elongated constant slope results in more surface area to monitor at closure. Next, and I don't have this figure on hand, but I would bet that if you were to put drainage ditches at the base of each one of these benches in the original landform to collect all of the runoff, the total length of drainage ditch to maintain would be much greater than the length of swale bottom to monitor in the geomorphic design. Now I say monitor because the geomorphic option is optimally self-healing, while these benches would not be. So a quick method of evaluation that we use during the design process is calculation of the topo factor, which is a basic slope area equation and gives a simplistic prediction of erosion risk. The image on the right is showing erosion risk superimposed on the landform. So that landform has a gradient in terms of elevation, so orange being at the top, that bluey color at the bottom, and then the erosion profile, risk profile, is shown in red to blue as well, unfortunately, but you can see it in these thin lines here. So you can see that geomorphic design results in these thin layers of erosion risk, which are often dampened by the propensity for dense vegetation to grow in these areas, as there's more water availability there anyways. On the area where the slope is elongated at a constant gradient over here, we see widespread erosion risk that is really unlikely to have the moisture variability that encourages protective vegetation. Now, I've included a rather dramatic photo on the left because it illustrates that swales like this focus erosion into the bottoms of them, the bottom of the channel, just like the red line at the base here. These designs focus the erosion risk so that your monitoring plan can be similarly focused. So each of these tools allows you to sequentially reduce the risk associated with a design according to the design stage. At the most detailed end of the spectrum, LEMs tell you what site-specific conditions or locations are at risk of geomorphic change, such that you can adjust your existing design where it's needed. For example, if your cover prescription for this structure is 1 meter thick, and the LEM indicates that under all climate scenarios modeled, the structure rapidly develops 1.5 meter deep gullies, then you have an opportunity to adjust your design accordingly. Now, there will likely still be some erosion once the landforms are constructed, but a system as close as possible to equilibrium has been designed, and continual enhancement and improvement of that system will occur with vegetation growth and with ongoing exposure to nature's forces, so wind, water, gravity. So I just wanted to finish up here with a list of kind of reminders for when you're working with geomorphic design and what makes them optimally positioned to manage risk. So for one of these designs to optimally manage risk, it really should be an integral part of the overall mine waste structure design process, and therefore part of the early decision making. It should, and I think I mentioned this earlier, be built with redundancy to reflect the degree of uncertainty that is present. The approach to design really should be systematic and structured. These are engineered structures, and the design process for a geomorphic design may be different from traditional topography, but certainly not less rigorous. These designs should be based on the best available information, and I would even add to that they should use the best available technology, and they should be tailored to the site. So you can't pick up a geomorphic design for a structure in Western Africa and plunk it down in Western Australia. These are tailored to the environments and the materials. The designs should be inclusive of human factors and constructability. I mean this in two ways. So first, that it's optimal to design these with the thinking of what is going to be constructing them. So using turn radii, for example, that the machinery on site can attain. And also with respect to end land use, of course. So if you know the local community intends on a particular end land use for the structure, we should be designing these things with that in mind. One particular example that comes to mind is a project in Latin America where buy-in for the closure plan was needed by a local indigenous group, but the landform design called for a structure that would block the community's summer solstice ceremony, which was very important to them. So this was not a monetary risk per se, or a risk in terms of technicality, but certainly a social and community risk to get further buy-in. The designs need to be transparent and inclusive. We need to demonstrate how we're doing this. We're not just pulling it out of a black box. And lastly, they really should be responsive to change and similarly capable of continual improvement and enhancement without detriment. So they should be eroding minimally per your design while depositing eroded sediment on site, for example. I believe that is my last slide. So I'm available for any questions you might have. Thanks so much for your time.
Thank you, Nelcha. Very interesting to learn about these geomorphic design. That's going to be very... I was thinking that, do you, I mean, the importance of designing it geomorphically, do you think that the mining companies in general are taking this into account enough?
I think they're starting to, and that's really exciting to see. With a change in regulation, particularly, we see this moving in kind of what I would say is the right way. We see this happening a lot in Australia, becoming a regulatory requirement. And I think that shift is going to continue. You know, you see two mines next to each other, one designed with geomorphic principles in mind, and one designed in a more traditional way. And the results really are quite stark. It's incredible to see the amount of you know, rallying behind these things that the communities really are able to do. So I think it's a good thing. It's in the mining company's best interests. And the more we have feedback from the communities and from the regulators that this is the way to go, I think they'll continue on this trajectory. It's very encouraging.
Yeah. How much more difficult is it to sort of start out, reshape something that is already started to be constructed in a more traditional way than to start it, you know, from the very beginning with these geomorphic plans in mind?
Yeah, I think mines are very fluid. So even though you start out with one design, generally they change quite a bit. So it's not that much more difficult to be changing things to get, for example, what we would call a legacy site, or a site that's already constructed and have to alter it into a geomorphic form. We do that all the time, and it's not that much more difficult, actually. The difference comes with the materials that you have available to work with. So you have much more flexibility with those sorts of things when you can plan for this from the beginning. And the opposite side is if you wait until the end, you're kind of left constructing things with just whatever is kicking around. So much nicer to have options.
Thank you. You mentioned as well, you know, about building in layers of defense and redundancy. What does this mean?
Yeah, so I think if we were to go for a walk through a forest, we would see all sorts of things, but in the waterways, generally they have some degree of armoring. They have a form that is both directing and dispersing flow, surface water flow. They've got varying degrees of vegetation. So you might have more dense vegetation where there's more moisture. And all of these things contribute to the amount of resistance to erosion that is provided. So when we design one of these structure, we do that with these layers of defense in mind. So we might have buried armor in some areas and exposed armor in others that are perhaps more risky or more suited to a alluvial analog. And then we can tailor the type of vegetation and the rooting depth as well, so that we're not just providing a form, although we want the form to be stable. Once we provide the form, we also start to layer these things on top with the vegetation and the armoring, et cetera, to kind of provide backup plans in case the form is insufficient or you get an extra strong storm that you didn't plan for. With climate change and things like these, we've got increasing uncertainty. So important to look at them.
Indeed. Thank you very much, Nilchi. And I do again encourage all of our viewers to please share your thoughts on what our presenters are describing. So please share your thoughts in the chat box and we can talk about them together at the end of this session. Our next speaker has more than 35 years of experience, both working in research and industry in the field of mine waste management. He will present the results from a large paste rock cover trial experiment. So please welcome Professor Ward Wilson from the University of Alberta, Canada.
Wonderful, thank you for that. I need someone to give me a thumbs up that you can hear my voice. Excellent. Nelcha, you did a fabulous job. Thank you very much for that. It's a pleasure to watch you give excellent presentations, as you always consistently do. Anyway, I'm here to talk about the title that you see here, Designing Mixtures. It's a design of mixtures, but I really should have changed this title as Designer Waste for Closure, for value. But I didn't change the title because it had been established some time ago. But I want you to think about waste in a different way, and that's the purpose of this talk today, is that you can use your waste to add value. You can create value that you didn't expect you had by designing your waste systems in a very sort of innovative way. I'm going to talk about what we call paste rock. There's other words, it's commingling, there's new terms. This is becoming very popular. But what you see, this is a slide that I took in Papua New Guinea. That's actually me with my colleagues, and we're mixing waste. We're actually mixing the rock with thickened tailings to produce an ideal material for full impoundment design, for covers, for closure. What you see here is that you fill the matrix of the rock with a consolidated paste tailings, and you get the strength of rock, and you get the low permeability and the sealing characteristics of the tailings. And you can create wonderful materials for full stage construction or even for closure. So that's sort of the concept. This was illustrated with a number of very large field trials. This goes back quite a few years, but you don't get a lot of opportunity to create these sorts of experiments for field trials. This is in Sudbury, Ontario. This is a beach that needs to be closed, and so you need a closure material of some sort. In this part of the world, there really is nothing. There's very little clay, very little tills, and so forth. And so the whole purpose of this study or investigation was, is it possible to create a closure material, a cover material, using waste? You see here 5 large lysimeters. These are about 15 meters square. There's 5 of them, 1 for control, 4 others for different mixture ratios. And I'll show you how we did the mix in a minute. And to compare, there's sumps at the bottom of every lysimeter, and there's an outfall and a drain. And so we can actually measure field performance with time. So covers, as we know, are an integral part of closure. They're actually alive, they're living. They have to control fluxes, they have to control oxygen and CO2 transport, and they need to support life and vegetation, and they have to protect and isolate a barrier, create a barrier for the materials underneath. So what do we have? We don't have till, we don't have clay, we have, but we have mine waste. And the problem is we look at mine waste, do we ever look at it as a resource? What you see here, and I should have my pointer up, but I don't, you see my boot there. We have high sulfide tailings. We have underground waste rock, muck, and we have slag in this case. And what we're going to do is say, can we design a mixture, a designer waste by mixing these three materials to create a cover system. So here you see a very simple illustration of using each of the materials. We have the tailings themselves, we have the slag, and we have the waste rock. And can we blend these in different ratios? And you see here a blend 1-1-2, and that really refers to using 2 units of tailings to 1 unit of waste rock and 1 unit of slag. So and you get it. You change the gradation. You get a well-graded mixture. And that's what we're looking for in the performance of many ideal materials, is sort of the control of gradation to create the performance we want. Now, many of you will recall the Equity site in British Columbia, and that was a world famous ARD site, and they had an ideal closure material. In fact, it was a waste rock or a glacial till. And you'll see that this blend 1-1-2 is the same as the Equity till. So rather than creating a large excavation and harvesting natural material, it's possible to create the material you need for closure by using your waste. And that's value. That's tremendous value. It's a designer waste. And so I'm going to show you the performance of how this blend 1-1-2 performed over time with respect to controlling infiltrative fluxes. So here is the creation of these materials. I shouldn't show people cement mixers and blending and it's not that hard to do. You can do it on conveyor belts, but in this case, we needed a control. What you see here is one of the lysimeters. They're all lined. We actually filled the bottom of the lysimeter with the same sand tailings, and then we created the paste rock cover on top. 2 of them were 1 meter thick, the other 2 were thinner but compacted. So in this case, there's no compaction. It's just placed as a mixture and allowed to drain and dry with time. And here you can see, actually, I'm literally standing on the paste rock right after deposition. And you wonder, how is that possible? This is soft, but in fact, this particular design had the full rock size up to 8" minus material. And you could see it was trafficable. In the background, you see the controls. So there's 5 cells, 1 control, and then there's 4 others with different thicknesses and different mixtures. So there's your control, just to compare performance. We have a full water balance. There was, you'll see all the way around, you have runoff collection, and we're measuring that to see the water balance. And the other sites, this is a paste rock cover. This is one of the compacted covers, and we left it in exposed to the atmosphere in sunshine for a year. You'll notice that it doesn't crack, and that's because it has a fabric of rock that makes it very incompressible. And so it's an ideal cover and very dense. We have tension lysimeters to measure performance. There's an illustration of what the material looked like underfoot. Very dense, very strong, very low permeability. And once all of the different covers were created, you'll see 4 in here. So there's your control. There's a 1 meter cover of uncompacted 8" minus, a 2" minus, same material. And then the last 2 in the back, 4 and 5, are thinner but compacted. So you'll see the outfall for surface runoff, and you'll see the underdrains underneath. Full water balance, dipping bucket gauges. We had this run for a full year. And what we learned is that the compacted covers compared to the non-compacted covers still gave no runoff actually from the control. That's why the infiltration was so high. But you can see you control the water balance with the permeability of the material. So there's the outflow data. I'm trying to get through this very quickly. So there's your control. This is flow. We get about 800 millimeters, 900 millimeters of annual precip. And so that you see in the beach, the control section, just the sand tailings, beach tailings, that you have an outflow, an infiltration rate of about 500 millimeters per year, which is more than 60% of infiltration. And that's what's going to be generating ARD. The non-compacted covers, just blend it, put it out there, leave it, let it dry. You'll see there's a reduction in infiltration rate, enormous, fourfold almost. But what was most amazing is that when you lower the permeability and compact the glacial till, so to speak, you get very low permeability and almost immeasurable infiltration. So this was an exciting discovery and something that illustrates how you can create a designer mix to produce great value for closure using your waste streams. Now, I lamented whether I would show this picture or not because it looks like things aren't attended to, but I had the opportunity to go back to the site years later. And like, you know how mine sites are, you build a complicated experiment, but we get busy doing other things. But when I went back to the site, I got over it. Actually, the drains were still functioning. And that's L1, that's a tailings cover. It was flowing. This is in the spring of the year, right after snow melt. And there was considerable outfall still occurring. And we took, and I haven't got the data will be showed at an ICART presentation next year in Sydney. But we have an outfall here of high infiltration rate, spring melt, and the pH of that water was, and I'll just say it verbally, we measured it, the pH was in the order of 3. We went over to the highest, the best performing cover, and you see it here. Now, do you really need do you need to go and measure the flow rate to know if this cover is working or not? So there's the water ponded. It was sitting full of water. The runoff, the surface runoff drain was plugged. And so all of the snow melt just melted, of course, and accumulated on top of this cover. But there was virtually, it was performing as well as the day it was first evaluated. And so we often, I know the Swedes worry about freeze thaw, and so do we in Canada. How well do these cover systems perform into the future during the extreme climates that we live with? And this, because of the rock fabric and the density, the material doesn't crack. No cracking, the permeability was still very low, and it gave excellent performance. So in summary, I'm done. That's basically what I want you to be able to understand, is that we can take our waste, we can create designer mixes, and we can create the performance we want with our mine waste. And so that's of great value to our industry as a whole, for closure, for construction, however you would like to proceed. So there's a bit of a summary here in terms of designer waste and mixing high density, low compressibility, low permeability, great for covers, full depth deposition if that's what we're really after. You need to have dewatered tailings. You can control your waste. By the way, I haven't published the pHs, but the pHs of the low flow lysimeters came up from 3, I won't say, but almost neutral. Anyway, so that's it. Our objective is physical and chemical stability, and we can achieve these if we design our wastes carefully and with purpose. So that's my presentation. I have one more thing. I just want to thank you for your patience and letting me get through this. I also just want to draw your attention. There's another conference coming in 2 weeks. It's here in Alberta. It's the Tailings and Mine Waste. It's the annual conference. It's given every year. It's in Banff, Alberta. And you can see the web page here. Probably some of you know about this, but I just thought I should let you be aware that there's another event coming in 2 weeks. So that's my chat. Anybody else? If there's questions, or I turn the floor back to our chairperson. Thank you.
Thank you very much. Interesting. Yeah, so let's all meet in Alberta in the beginning of November then.
Well, our borders are open.
Yeah,
And I think,
excellent.
yeah,
And we can leave the country too, so.
Oh yeah, well, come on, come and join us. So, but there is a virtual component. So if you can't, and just the way we're doing this now, and so we're doing both because we weren't sure how things would turn out at this time of year, but we're fighting like everybody else. We're still living with COVID.
Yeah, unfortunately, still it's remaining. I was thinking about how are the Nordic countries doing in these terms? Are we performing well? I mean, in the designing and experimenting, the R&D in the field that you are.
Yeah, no, we are. I think we are. The topic I have just alluded to or talked about, this was research. This is 2 decades of research, but the practice of blending rock with tailings is now taking a firm hold, and there's a number of sites worldwide that are actually piloting and implementing this technology. So there's another side to this. It's not just for water quality and ARD, and it also to get rid of tailings impoundments, because as you well know, we've seen some very significant problems with failures of tailings. And so you solve 2 problems. You get strength and you get environmental control. So it's physical and chemical stability combined. Yeah, so that's and I think you're quite. Is it Nordic countries or is it? Yeah,
the Nordics.
But, yeah. No, this is our main problem, is that we have to deal with from -40 to +40 pretty much.
Yeah.
Through this full range of climate, and that is a great challenge. And so I know that Sweden has this same. Actually, when you come to parts of Eastern Canada and you walk around, you'd think you're in Sweden. I'm not kidding you. The terrain, the vegetation, very similar. So.
Yeah.
Yeah.
So thank you much again, Professor Wilson, for this. I believe I've heard that we have had a few questions in the chat. So now I hand over to Annika for leading that part.
Oh.
Yeah, thank you. We've had 2 questions coming in for Nilce, which is kind of similar. The one is regarding the landscape evolution modeling. Has or is there any ongoing studies to compare the modeling results with how the landform is performing in reality?
Yeah, so we've used these landform or landscape evolution models, these LEMs, in a few different ways. One of them is to predict future performance. And the other way is to predict existing performance. So we've used past historic climate records and vegetation studies and whatnot to predict existing conditions. And they seem to work fairly well. So that gives us confidence in our predictions moving forward. I'm not sure of any studies that have looked at geomorphic designs in mine waste, but that's a great idea. And I'm sure if somebody's not on it now, then that's something for me to add to my list.
Yeah, thank you. And the other one was regarding how can you in this design manage multi-layer covers where you have sort of importance to different layers in your cover system?
Yeah, it's a similar construction to if you were to design a cover system on any other landform. We generally are working with slopes regardless. And in our geomorphic designs, they're just, they change more often. So quality control is certainly an issue. But we've done these designs for all sorts of different landforms with potentially acid generating materials and covers of various depth. So it's certainly possible.
Yeah. And also a question for you, Ward. Consider best material blending as a cover that also consider vegetation establishment, as long as physical and chemical stability.
Good to see you, Annika. That's an excellent question. I thought about that. I didn't articulate that in the presentation. The cover system that you saw in this presentation was certainly to create a barrier. But you'll notice, if you recall the slides, you see they were vegetated in the end, and so there was a topsoil that was placed on top to actually provide a growth media for the seed base and so forth. And so there was two components. You still need some real soil to revegetate, and so we're not suggesting that you're going to use tailings and and waste rock and slag. You can, but they were actually there for the barrier to control fluid and oxygen fluxes. You still need a growth media. So, and it was relatively thin, but good point. Thank you for that question.
Yeah, thank you. I think that's
it,
all from
Annika.
here. Yeah, thank you, Emma.
Okay, so thank you, our speakers from the third session. That we now will wrap up by saying that we are heading into a short break, and we see you back here at 4 o'clock Stockholm time. So in 19 minutes, more or less, and then we will continue talking about landform design, and we will also bring in the perspective of the indigenous perspective, bring in the indigenous perspective into these discussions about the reindeer herding requirements and aspects of old mine sites and reconstructed sites. So thank you very much. So see you at 4 o'clock. Welcome back to the last session of today's seminar, Creating Value Through Closure. As we have learned, the design of tailings facilities is crucial. Gord McKenna from Landform Design Institute has long experience in mine operation and international consulting for oil sands, coal, diamond, and metal mines. Gord is talking today about landform design for tailings facilities, the need and how to do it, and some examples of elements to consider for your landforms. So let's find out what he will tell us.
Great, thank you very much, and I appreciate the chance to speak at this seminar. We're talking about landform design for tailings facilities in particular, I suspect many of the participants in this esteemed workshop are already doing most of this work. This notion of landform design is breaking out worldwide and is being practiced by many. What I hope to do here on behalf of the Landform Design Institute is to introduce you to the formal process and some of the tools and some of the how-to specifically for tailings facilities, or with examples for tailings facilities. Our main goal here is making sure that we're clear in what is being committed by the mining companies, and making sure that we follow through on those commitments so that the users can get back on the land. Why do we need landform design or a step change or a more formal process? What we've seen is that mine reclamation has grown organically over about the past 50 years. Mine reclamation really started in earnest in around 1970. And it's been advanced by Herculean efforts of individual practitioners, and it's done quite well. But as the mines have gotten bigger and as we're promising more, we're falling short of these grand promises, and we're learning more about just how much we can control in the natural environment. So we're over-promising typically and under-delivering, and crucially, it's very rare that users are ever allowed back on the land. So the mining is promising to be a temporary use of the land to get the users and local communities back on the land, reclaimed land within a few decades. And this is exceedingly rare around the world. Hopefully your site, you're having people back on safely using the land, but that would be less than a couple % of the mine sites worldwide are doing that. But things are rapidly evolving, and there's we recognize then a need for a step change in this behavior as being proposed in this seminar. Back on the land, reclaimed land within a few decades. Sorry, a bit of feedback on my side. And we talk about this landform design as mining with the end in mind. You would have seen equivalent slogans before. We're talking here today about risk-based design for the closure of tailings landforms, and you'll see that the landform design is based on such an approach, but it begs some really important questions. What is exactly being promised? What is being proposed? What is the design? What are the risks that the design will not meet and the performance will not beat that which is promised? And crucially, what are the contingencies here? What are we going to do? What are we promising to do and designing to do upfront? Should these risks come true? Should the performance be less than planned? Who owns the risk of this kind of performance? And when we're all done and everything is reclaimed, who owns the residual risk? And I've highlighted that in red because we've learned through interviews, especially it's crystallized over the last year or so, that the main holdup in getting land signed off by the regulator and local community and transferring the liability is the whole question of residual risk. In one sense, it's obvious, but hasn't been so obvious, just the central importance of this residual risk. There will always be residual risk, and it's not quite clear to regulators and local communities why they should accept this residual risk in the end. And so this notion of landform design offers a structured path forward to it. Just to anchor it one more way, and the global industry standard on tailings management came out, and you can see the 15 principles here. And I've highlighted in red a bunch that relate to landform design, especially the first few, meaningfully engaging the people who are impacted, having these multidisciplinary teams, developing this knowledge base, developing design criteria, a robust design, tailings life cycle. So these are, and the rest there too, but these ones that we're talking about here today. We all promise here tailings facility life cycle, and we're working on that. But I think most practitioners out there, especially the people who are more tailings minded than reclamation minded, are looking for how to advise on how to advance this. So this flow chart here is the essence of landform design. I direct you to go to our Landform Design Institute website, landformdesign.com. You can download this drawing and much more in our position paper that came out last spring. There's a bunch of definitions in that. But here's the basis of the process. One is forming your team, your design team, and we'll talk about who sits on that team. Establishing governance and who's funding it, who's paying people salary, who's organizing it, who's helping to make sure that all this work is being done properly. This is typically the job of mine management, but also may be coordinated as a panel with the regulator and local communities. You're going to create the third box there in blue, create a design basis memorandum. And here's where you're going to set out your vision in a page or two. What is it that we're all trying to achieve? What are the goals and specific design objectives and specific design criteria? So this is typically a 10 to 20 page document and is fairly detailed. You're going to go through and design the landform. That's where the bulk of the work is. You're going to go through and assess the risk. We usually use a engineering risk assessment approach to this, typically an FMEA. Some of you will be familiar, but there's a bunch of different tools. And then crucially, and this is leaning from the geotechnical observational method and improvement on adaptive management, we design the contingencies up front. So if there's things that might go wrong coming out of the risk assessment, that the trees won't grow or the water quality will have too low a pH or we're getting too much erosion, that you've got pre-planned contingencies in place that for which there's budget and time and will to do. With all that in place, then you go and construct your landform, and we're still placing most of the landform the way we would do before. By landform meaning waste rock dumps or tailings facilities, mined out pits, even the surface water drainage system forms its own landform, or in this case, management unit. And we'll go through and build it so that it's easy to reclaim and will perform well. So we're changing how we build things to a certain way. The paste rock that Ward talked about just earlier is an example of engineering a material to be have better properties for closure. Then we're going to monitor the performance of it, and during construction and during and after reclamation, we're going to be building about a dozen mining landforms on every mine site. Together, we call that the mining landscape, and it sits within a mining region. And so we're going to be monitoring each landform, each landscape. And if we're finding that the performance does not meet expectations, we will implement those contingencies. May mean going back and re-reclaiming or fixing some areas, may go all the way back to changing some of the design and some major changes in the landform. The arrows go up even further. Maybe our governance team isn't doing a very good job and they need to be switched out. How to keep us honest in all this, so we're not just promising and arm waving. There's an annual audit. This may be done by a review board, or you may be bringing in a consultancy, and they will check, maybe the regulator is doing some of this. Are you doing what you said you're going to do? Do you have your contingencies? So this is the process. This process typically lasts several decades. and it's done by a landform design team. It used to be just in the lower right, a reclamation specialist would be charged with such work, but we're recognizing the need to put together a fairly large team. You may not have all dozen people or so here on your landform team. Oftentimes we've just got 7 or 8 of these people, but it's certainly more than 1 or 2. And each of these people needs to learn how to work in a landform design team. It typically takes 2 or 3 years for the team to really gel and work well together. And this team will be in place as people will switch out, but the team will be in place over several decades as the mining landscape is designed and constructed and reclaimed and maintained. Actually, most of the sites end up getting a certain level of maintenance forever. And so this idea of walk away is seldom true, seldom comes to pass. And so this team will actually be a permanent team. You can see in the bottom, what my experience is that it typically is about 40% earth science and engineering types, biological science, management specialists, and a couple specialists at the end. This is, so I thought I'd spend a moment showing you, what does this look like on the ground? And this is from a drawing that Dirk Van Zyl and I put together for the GISTM compendium that was published last year. It's a large tailings facility as a valley fill. And you can see number 1 here, there's a small pond with some fishing in it that's been designed in advance, and there's an outlet that's visible where it goes up and to the right there, where it can discharge to the environment. There's diversions, 3 and 4 areas are diversions, and keeping clean water clean is a critical element. 5 is showing that our tailings areas generally need a little bit of diversity and topography, and so there's some ridges and swales set up there. Number 6 and 7 are ways of figuring out how much water is acceptable on top of a tailings pond. It can never be 0. We can never keep these things perfectly dry all the time in rainstorms and that, but there's a geotechnical buffer zone, a geotechnical critical zone that are explained in the paper about, and methods to keep the water away from the crest that would lead this to being a dam again. Number 9 here shows some landform grading to give us a little bit of a wavy crest to give it a little more natural looking. Number 10 is critical here, where we can seldom rely on sheet flow to avoid gullying our covered tailings, especially if it's a sand dam. Neilsha talked about that in her talk last hour. Here's one solution to it, and that is building from the beginning a really nice wide bench, 50 or 100 meters wide on your tailings facility, and using that to collect up the water and take it down an armored channel safely off the landform. Number 12 and 13 there show that you're providing access to the toe for long-term monitoring and any maintenance that's required that's built into design. Here's an example of some of the elements that you might incorporate into your design. June Pollard and I have a paper you can look up that's got 97 different elements and forms like a cafeteria list of things that you can choose to bring into your design. And if you've got more to add to that, we'd like to add to our long list. Quick case history in the last minute here. This is an oil sands pond in northern Canada. We were asked to come in and cap and reclaim this. It's got fluid tailings in it, essentially like chocolate milk. And the vision is that a person could walk from one side to the other without getting their feet wet, and to do that work within 3 years. It's about a 2 square kilometer area. So we did our landform design and sketched up our vision of what it would look like, bringing water through a series of swales to a very small wetland, and then draining off to an end-pit lake. Here's during construction, just after most of the tailings has been infilled and the soils have been placed down. You can see there's a couple spots with lots of yellow equipment. It was a very large project, 400 people for 3 years, several $100 million worth of work. And then flying over there a couple of years later, this area's got its nurse crop. It's largely complete. What you can't see is the 500,000 trees that are now growing quite well. So the Institute is up and running. We're just celebrating our 2nd year in there. Our goal is to make landform design routine in the mining industry worldwide by 2030. So we've got a few more years left in the decade here to finish this, and we're hoping that you go have a look at our website at the position paper and look to join us and join the worldwide community of landform designers. Thank you very much.
Thank you, Gord. Very interesting and very beautiful pictures too, drawings. Thank you. I would like to ask you, what is the single most important thing in designing a tailings facility for reclamation or closure, if you like?
I would argue that the single most important thing is having really clear goals, not over-promising, but being very clear that design basis before you start. The same way you wouldn't start building an office building unless you knew how many floors and what it was going to be used for and what fire codes would be involved. And that needs to be worked out before you start. Unfortunately, for all of us in the seminar, we're going to be dealing our entire careers with facilities that didn't have this design basis. And so it's never too late to start. In fact, it's the next step if you get asked to reclaim something.
And again, you were mentioning do you have some other important aspects to bring into this topic, other important aspects?
I think the key thing that I tried to highlight in the presentation here is that we'll often offer adaptive management, and it's kind of a vague I'm quite critical of the approach. It seldom works, even done well. And what's lacking is this pre-planned contingencies that you're able to monitor for and decide when to invoke and get those ready to go. So if you've got too much erosion, what are you going to do about it? If your water tables are too high, what are you going to do about it? You're going to try and design against these, but we can't get everything right in the first place. So instead of arm waving and promising to change in the future, you're going to have a good contingency for each risk that you've identified.
Mm. I mean, you and many of our other speakers have been, really stressing the importance of, planning ahead of time in what you will do sort of in the end or after the end, or as you put it very elegantly, mining with the end in mind. Do you believe that the mining companies and have this in mind more now than they used to have, or are you still, sort of struggling to get your message through?
I think that, well, just about all mines will recognize all mines have a closure plan now. Starting in about the mid 1990s, closure plans were common, and but in my practice, I find almost every single closure plan is too conceptual and is too optimistic and can't be implemented. So mine management might be thinking, hey, my professionals, they've given me a closure plan. The regulator has said, okay, but we find that they typically contain fatal flaws and are typically over-promising what can actually be delivered. So I think that's the mines have the best intent. We, as professionals, we all have the best intent. But we need a greater level of detail and avoid overcommitting as part of that closure planning process.
But again, what needs to be done to meet that goal? I mean, to get your message through all the way, that there's no use in making all these plans and elegant drawings if they're not used.
Exactly. So the Institute has a plan for dozens of these kinds of presentations, but also offering courses around the world and teaching professors. We're hoping to have a dozen universities teaching landform design around the world within the decade here, at least one course and maybe a couple offering a degree in the process, and developing this, database of 500 case histories by people like yourselves. We're going to make it easy to put those together, and we're setting up to have some case history every 2 years, having a case history symposium for people around the world. So yeah, the goal of making this common in 8 more years, we've got a process laid out for that, and we'll see if we're successful. I think it'll depend so much on people stepping up and contributing to it, and there's very little work, sort of international groups working on mine reclamation. It tends to be local at the country or region based, and so opportunities like this international conference are so important.
Thank you very much. Thank you for now, and please stay connected. And we hopefully we have some questions or comments that our viewers will share, and maybe you can jump in later. Thank you. Our last speaker today will bring in yet another perspective on this long-term mine closure. Jenny Wik Karlsson she's a senior legal advisor at the SSR, the Reindeer Herders Association. They work together with the reindeer herding communities in consultation processes and develop policies and strategies on a national level. So now I leave the floor to Jenny.
Thank you, and hopefully the sound's all right. We have some problem with the internet during all day, actually. So I'm glad it's working. And
They work together with the reindeer herding communities in consultation processes.
I hear myself in double at the moment, and you will see my screen as well now. Yeah. Yeah, I have presentation. Do you see it? Yeah. Do you see it in presentation mode, or do you see it in 2 pictures? Yeah. And then, so, yeah. And now you just see one, actually. Well, yeah, thank you. And hopefully you're not too tired in the end of the day listening to very many interesting presentation. This is a picture from our 100 years of anniversary, celebrating the first organization of the Sami within the FMEA, which was held in Östersund in 1918. This is not from 1918, it's from 2018. And this is our members. As said, I work as a senior legal advisor, and will give you some perspective on what to think about when talking about restoring land, because this is actually what it is for us, restoring our land, if it's possible or not. Just a very short review of what our organization are. We work with the reindeer herders, for the reindeer herders, and trying to create a sustainable reindeer husbandry for the future, both on economical, legal, and perspective, but also in order to try to actually today, it's more or less trying to cope with climate change and trying to deal with a lot of different tough questions. The land is shrinking, and we have quite huge impact of climate change within the Arctic that is affecting us. Well, let's talk about what we can call it your responsibility. As you say, it's an open pit. It's actually from ITIC. On the other hand, you have reindeer herds, as you can see far back. You don't want to go close them. It's on winterland in the mountains. And this is a little bit what restoring is about. Of course, we know that a large mine, open pit like ITIC will never be like the picture with the snow here. But we're glad that we are talking about how to create possibilities to transform sites of mining to reindeer land. We're not really sure if it's possible. Hopefully you have a lot of engineers that will come to that conclusion that it is, and maybe it is possible in a kind of ecology or biological way, but then you have to learn the reindeers to go back, and it's a different that's a different question, and there the reindeer herders needs to be a quite big part. But nevertheless, I would talk about I would like to start with this question, with this picture, because every time when we talk both about closure or the beginning of a mine, EPs, who stand for indigenous peoples, are often expected to participate and compete in a market-based economy, even when we talk about closure. And from my point of view, and for those I represent, actually this is a question of our basic needs, our human rights. We need our grazing land, we need food, we need shelter. And there you have a kind of gap between the economy contra the gap of traditional livelihoods and indigenous people. And I want you to think about that when you approach the indigenous people, not only in Sweden, in the whole world, that this is two types of societies and two types of knowledge and need to be recognized as this as well. We can say that we have a kind of reality check to do. And actually, from my point of view, and from when we talk about closure, closure for me actually starts in the beginning when you apply for a mine. Because only talking about closure or only talking about how to get a license to operate, if you don't connect them together at the first beginning, we will have a kind of huge gap between the dialogue with the Sami communities. Because at first, and we need to realize that when a mine is open within the traditional Sami land in Sweden, it is a piece of land that will be for a few years gone. And I think we have had, not all of them, but we have had some bad examples when a mine or just has started and then the company has didn't have the economy to fulfill it and just left the place. And we do struggle still with some areas, even when the mine has stopped. For example, we can take Stikenjokk in Västerbotten County. There is no mine there today. It's an underground mine and it's traditional up in the mountains. It's stopped in the 1980s, but we still have, even it's pasture land, but we do still have problems. We have roads and so on and so on. And we need to learn our lessons from that, how to do it better. And better always start at the beginning when you have a project. Because it's a matter of coexistence, both during the minings, when the mine is open and when closing. And we talk about on equal terms, and it's important to have that in mind. Today we're not equal, not in knowledge, not in economy, not in personal human resources, And we need to start to make an approach to that. We need to set terms that we can participate on equal conditions. Because the challenges, which this is both for closure and for startups, it has always been, when you talk about indigenous, such as Sami, has always been done by the Sami, and often without influence, capacity, and consultation. And we always relies on goodwill from others. And in the best case, this goodwill is there. In the worst case, it's not. But our work is to have our traditional livelihood. Reindeer herding is still nomadic, and we need to have our green infrastructure, meaning we need to have grazing lands to move from mountain towards the coast. And if we go back 100 years, 50 years, we did still have the possibility to use our land flexible. But today, because of climate change, because of exploitation of the land, of shrinking pasture land, we need to start asking ourselves if that's still possible. And therefore, this kind of initiative, when closure and trying to restore some land, it's good if it's done right. And therefore, we need to look back some way in history, because always when we do impact assessment or assessment all over, it's always assumed that today is the starting point. But it's not. This is quite a bad picture, but this is symbolize our lavo, our traditional way of living, if we go back. But it's 3 fundamental legs. And we need all 3 of these legs. We have our nature, we have our spirituals, we have our culture, and we have our people. And every one of these legs are necessary in order to have our culture still there, be able to continue with our traditional livelihoods, such as reindeer herding. If we have imbalance, the level will fall eventually. And therefore, again, important with consultation early. Sorry. And I've been listening to you, and a lot of things you talked about is balance between 3 circles. Values based on equality and balance, and environmental, social issues, economy and legislation are 3 equal circles. So that's the goal, I hope. And we go to this from this, because this is Mickey Mouse. And this is our point of view, actually, when we talk about how we look at it today. Maybe it's not fair, but this is from our point of view. And you see, we do still have a lot to do. We have the heirs with environmental and social indigenous question, and the larger circle is still politics, economy, and legislation. So we need to equalize and have a balance in this circle. Well, what can we do then? Well, to begin with, consultation and participation. These are fundamental rights of indigenous people, recognized in convention, in legislation, and so on. And we need to start practice this fully. And it is not an ad hoc activity. We have to do it as a process, meaning, again, don't start when you close your mind, start at the beginning to talk even about closure. Well, so now what to do? Yeah, we have to learn from our mistakes, because we have all made mistakes. Or I can say, when we talk about policy making, it's the state learning from us as with our traditional knowledge about the land, about land use. And we also need to recognize that sometimes we're not going to be able to reach any agreement, but that's respect as well, to recognize that. And sometimes when we talk about coexistence, it's just a word. And a little bit of shifting minds, think different. And this is a good startup, talking about closure in different ways. And of course, responsibility and courage with the companies to step up, and also changing in governance and legislation. This is not only a question for indigenous people. For me, it's a question for Mother Earth, actually, to be able to live longer and change direction what we're going today. We have, from our organization, have a policy, what to think about when collaborating, working with indigenous, both in project or in negotiation and consultation processes. And some key points here from them that you can take with you is that identify what positive and negative effects that can be expected from when we participate, we as an organization or the stakeholder, how the data will be given back to the Sami, respect of our culture and the values. We also talk a lot about free, prior and informed consent. I haven't talked about it during this presentation, and I will leave it a little bit aside. But have an individual agreement with the community. And if you're interested in this policy, we have it in English on our website. So it's kind of good to look into it because it says a lot. Because the world is still knocking on our door. And I think this is a good question that illustrates what we are standing and what we are facing. And when you plan closure or plan a mine, you have to take it on a landscape level. You have to have knowledge not only about today, you have to check the history and also recognize and respect the traditional knowledge of the group you are working with as a source of reliability. And also have respect that our goals often are not the same as a lot of companies. It's not business as usual. For us, it is about our life, our culture, our way of wanting to give the coming generation a choice to continue our traditional livelihood. And for that, we need land. But also in Sweden, reindeer herding is a core of the rights of the Sami, which is based on customary law and based on grazing. So that's important as well. We need to continue grazing our reindeer in order to have our rights still there in the future. And that's all I was going to say very briefly during this short 15 minutes. And thank you for listening.
Thank you very much, Jenny. I was thinking you were touching upon the fact of consultations, and what can mining companies in general do to make it easier for the reindeer communities to participate in these consultations?
I think one of the key issues is to start early, not come to the community when the process is more or less, the project is ready to launch, to invite them to an early process, and also to listen very carefully on what they have to say, and also make sure that time and resources are available for the community in order to take a part in a consultation process.
And I guess, I don't know if you were listening from the very start, our first speaker, Hanna from FMEA, she mentioned that she said something like a social license to operate isn't a license you can apply for. It's something that has to be that you gain along the way. But I was thinking about consultations are, they are formal to the nature. What are your thoughts on like more informal ways of contact, keeping an open dialogue and so forth?
Well, I would say that informal dialogue is good. Although I think, and that's based on history, I would say, you need to have both. You need to have a formal process. You talked about gaining trust. And there is a bag of history that companies today, they will be not necessarily is not mistrust the company, but the history of a colonial perspective will affect the dialogue. So I think informal and formal, and that's trust on both sides, and I think that's necessary. But so both.
Okay. There are a lot of aspects of modern society that really do affect reindeer herding. I mean, we have roads and we have other kind of infrastructure. We have cities, we have hydropower, wind power, mines, active mines, and we have how big a problem or challenge are these rehabilitated or restored pieces of land that comes from a closed mine?
I would like to actually think that I would like to see them not as a problem, as an opportunity. If we can research and we can gain lichen on the ground, for example, and restore to grazing land again. And I know it's a research going on that field as well. So the problem of closed mine, or as I mentioned, Stickum for once, is that you still have, it's not perhaps the mine itself, which is an underground, it's the roads that were made for the mine at the beginning that today are used by tourists, for example, and this is on calving land, which causes huge problems. So the planning of a mine, therefore I wanted to highlight the planning of a mine and closure of a mine should be in the same process to address this question, at least at the early start. I know it's hard to talk about closure in the beginning, but at least have some thoughts about it.
Yeah, and I guess that's one of the main messages that we been sort of trying to get through during this afternoon together. Yeah. So thank you, Jenny. But stay connected, because I believe we have some comments from our viewers and questions in the chat. So I hand over to Annika.
Thank you, Emma. Yes, that's right. We have some questions, and going back to Gord's presentation, there's some technical questions. For tailings facilities where there is tailings that has been assessed as contractive, what measures are you taking for keeping all the tailings stable?
Yes, and that's a big issue that could have its own conference, as you know, Annika. It turns out more and more of the tailings that we replace hydraulically, we're finding out are potentially liquefiable. People are doing work and even the dry stack material, if it's not properly compacted and becomes saturated, has this issue. And I've got several projects I'm working on where people are dealing with this. If you design in advance and make sure that there's nothing contractive or liquefiable and no ponded water anywhere near the dam, that's really important. When something is potentially liquefiable forever and you're trying to close the facility, it's very difficult. There are methods to densify that material, but they're costly and not always effective. We end up often having to build large tow berms and flatten the slopes to try and make sure if they did liquefy that they won't move anywhere. But that's a major issue. And then if we can move towards filtered tailings and or other materials that we can reasonably assure won't be liquefiable, that's an important step.
Yeah, thank you. I also think that maybe the my own thoughts now, maybe the geomorphological design with most of the time flatter slope than the strictly engineered structures will sort of also be beneficial for the stability.
Yes,
not just
both.
to erosion, external
Yeah.
erosion, but internal stability as well.
Indeed.
And I haven't seen so many projects where tailings facilities has been designed with a geomorphological design in mind. It's been, as far as I know, more to waste rock dumps.
Yes, and people are hesitant to move away from our conventional designs. So we need to, part of the Institute's work in putting together these 500 case histories, hopefully that's just a start that we can start to share. I'm sure there's some out there. We've done a couple using the geomorphic approach, but not very boldly. So if we can get more people to contribute their experience in that, we can learn from each other.
I guess that's also will include maybe extending the footprint of the facilities when you need flatter slopes. So that's also a process.
Yes, and perhaps not using sand dams and using more conventional dams to hold them, so we're not into some of the issues of piping and erosion that are common with the sand dams.
And then there was another question. Do you utilize geosynthetics in your landform designs?
Yes, again, a little bit of a complex issue because we try not to use geosynthetics because of their limited lifespan, and we often think, like a filter cloth or geogrid can only last, or pipes, plastic pipes within the dams only have a lifespan of 50 to 100 years. We're trying not to rely on those in the long term, but we are using them sparingly for short-term stuff, where oftentimes, for capping or different things like that, we will use them where we're not relying on them to last more than a few decades. But we're still learning how to walk that fine line.
Yeah, thank you. And then also some questions for Jenny. Very interesting presentation. One question is if you have any examples where, from your point of view, the closure of a mine has been successful. If you sort of have any good examples that could be a model for other mines.
Those examples are a little bit way too long back in order to be good. So you have Sticken, you have lava, and you have some fuel. So I think there are still to explore. Therefore, we could be a little bit more positive about it. So not on sitting here just getting an example in modern time anyway.
Yeah, maybe that could be an area where we could sort of on the national level work on kind of an agreement to a very generalized goals, what's important, and at least clarify that for each operation, what's going to be important.
That's good. There are a lot of small projects about how to get leaching back on the ground and ecoducts and so on both some mines that are going to close, but also the mostly today is about before opening a mine or how to adapt on a mine that's already on site.
Yeah, and then also I guess Emma already gave that question more or less, that how should a cooperation be done between the indigenous people and the rest of society? What would it look like? How could academia contribute?
I think they can contribute in many ways on what's going on today on research, but on L2 and other areas, and try to work together in different perspective in both in society and local, look into how has it been done in, for example, in Australia, Canada, which also work together with the indigenous group, and trying to learn from them. But in the end, it's the community and the company that needs to set their own process, because that's one part of a good consultation, is to create the game plan between the company and the community, reindeer community.
Yeah.
And we have some guidelines, as I said, and you can read it, and it's even about researchers on academia, how to work together.
Yeah. Some more questions are coming in here for you, Jenny. You raise many important issues. Do you have a good contact person for that I can contact for further cooperation on this?
They can contact me, and we can a longer talk with those who want to. And I guess you have my contacts.
Yeah.
Details. So
we can help out if Christina, who asked the question, don't have your contacts. She'll contact us, and we make sure she gets in touch with you.
Yeah.
Yeah. That were all questions from the floor. Back to Emma.
Okay, thank you very much. Thank you, Jenny. Thank you, Gord, for contributing to today's seminar. Well, and thank you everybody else for watching today, and thank you for sharing your thoughts in the chat. Very valuable for us. Trying to wrap this up, I'd like to repeat what I mentioned at the beginning. So at the beginning, I was already thinking about the closure of this seminar, okay? Keeping the closure in mind at an early stage, way before it actually is about to, way before it actually begins, it will get easier in later on. So long-term closure plans made already during the active mining production phase will save not only time and money, but the nature. That's about it. So this conference or seminar is a biannual seminar. So if we don't meet in Alberta in the beginning of November, we will meet for sure in October of 2023. Well, this is it from Stockholm today. Over and out.